Higher-rise it's true. When I was doing research,
Good morning. Good morning, everybody. We will start now. We will start now the plenary session of this morning. My name is Jack Briggs. I'm professor at the University of Chile and also senior researcher at SMI ICE. We have an interesting set of presentations this morning. The first one is in charge of Dr. Mark Dogstajter. Mark is currently associate professor at the Trent University in Canada in the Charney Wenchek School of Indigenous Studies. He is a former president of the First Nations University of Canada. He's also a member of the Oneida Nation of the Thames, and he received his PhD from Osgoode Hall Law School of York University. The presentation of Mark is titled "The Relationship Between Resource Extraction and Indigenous People in Canada, an Overview." Mark, please.
I hope everybody can hear me. I'm not going to use the microphone. Is that okay? All right, small enough room, good. So let me start out with saying good morning and Sego, Ani, Kanse, Wapsani, Mushkuna Makwa, and Vijna Kaskwa, Dancy Dodom. I'm Haudenosaunee Mboemwe and Ganya Gayaga. Introducing myself, I am Haudenosaunee from Canada. This is a map of Canada, by the way. I heard it was an upside-down dinosaur, but it's not. It's an interactive map that we're going to be using. So I'm from this area of Canada, southern Ontario. You might know us better as Iroquois or Mohawk. We're the guys with the head, the fancy haircut, the Mohawk cut. So Umgoyomwe refers to the idea that we refer to ourselves as the original peoples of the land. Haudenosaunee means that within the original peoples of the land, we were a confederacy of 6 nations, and we were the people of the Longhouse. That's the structures that we built. And I'm a Mohawk, which means I was one of the nations of the confederacy. My traditional name refers to a bear who gathers white rocks. And what that means, white rocks are interpreted as knowledge. So if you know of bears, they scratch around, they move things under rocks looking for food, and I'm representing, in my traditional name, the one who gathers knowledges and keeps those knowledges. I'd like to also give my greetings and thanks to the traditional peoples of this land in acknowledgement of their territories and their lands and their hospitality in allowing us to gather today on their territories. I'm going to take you on somewhat of a different ride this morning. Everybody's familiar with Monty Python, and now for something completely different. So now we're going to go for something completely different. And I'm going to speed through a lot of things, but I'm going to try to give an overview of Indigenous peoples, their relationship to resource and resource extraction in Canada, and I'm going to try to give you the big picture. Sometimes we get lost in the details, and the details don't show you the overall impact or the cumulative impacts of Indigenous peoples and all the relationships that they have with resources in Canada. I'm going to start out with a prop. If you don't know this is an actual magazine. It's not interactive in any way. You actually have to open it, you have to read it. A lot of students these days really don't have newspapers, and they don't actually use these kind of documents these days. But this comes from our national newspaper in Canada called the Globe and Mail. And inside the Globe and Mail, they have an insert. It's called the Report on Business, the ROB. And the Report on Business is a prestigious magazine that gives you sort of insights into the issues of the day. On the cover of this one, and this is something, and what I'm going to do is give you a snapshot very quickly to give you kind of a different story than probably you might know about with Indigenous peoples in Canada. Not using that yet. On the cover, we have Chief Crystal Smith. And Chief Crystal Smith represents a new wave of business in Canada. And Crystal Smith, it represents the Heisler. And the Heisler, no, I'm not going to get a whiteboard, so I'm using it. So, in homage to Ken Coates, this is the Yukon, this is the British Columbia, and the Heisler are located on the coast of British Columbia. And a First Nation that is involved right now in LNG, liquefied natural gas. So there's a big natural gas deposit here, and the idea is, well, how do we get that to market, which is Asia? And the idea is a very simple one: we build pipelines. What the report on business is saying is that why Canada's future depends on economic reconciliation with Indigenous communities. Now, it's not too often that you hear that a nation and their economic future depends on Indigenous peoples, getting along with Indigenous peoples, and having a relationship that is positive with Indigenous peoples. But now in Canada, when we talk about the economy, when we talk about jobs, there's a third leg to that stool now, which is Indigenous peoples. If you're not in a partnership, and if you're not including Indigenous peoples in your projects, the chances of them happening are less. Some say zero, but if they do happen, it's going to take a long time. So the best way to conduct business in Canada, as the magazine is pointing out, is to have positive relationships with Indigenous peoples. So I thought, because I gave this to my class, and I said, why would the Heisler be on the cover of the report on business? What's so important about Indigenous peoples in business in Canada? Why has things changed so much and so fast that they now say that our future depends on this relationship? And when you look at the Heisler and you say, well, what's that project? And this is an exercise they gave my class. I said, let's go through and see how many times the word billions of dollars are associated with Indigenous peoples now, within the last year. And let's take this as our starting point. So the Heisler terminal, we'll say, is $3+ billion. So the idea is to get the resources to market, build a pipeline, build a terminal, and then come in and then ship it up to Asia. These terminals and the business surrounding them, in this case example, the Heisler, says that, well, we're not just asking the permission of Indigenous peoples, they're partners in this. So the Heisler are partners in this $3 billion development. Sometimes they're majority partners. If you look a little north, another First Nation, $2+ billion, looking at the same kind of terminals and pipelines and all the associated business associated with these particular developments. And so I said to class, what other billions of dollars have we heard in last year? If we stay in BC, we can look down here to Vancouver. And in downtown Vancouver, the Squamish are building a new residential tower, a residential complex. And that is $2+ billion. That's not all they're doing. They're in partnership with a couple other First Nations in Vancouver, and they have between them another parcel or parcels of land in downtown Vancouver that they're going to be developing, and it's multiple billions of dollars as well. So plus billions of dollars. You say, well, that's only the West Coast. What about the rest of Canada? Are there billions of dollars associated with that as well? And say, okay, let's go to the other coast. Let's go over to the East Coast and talk about the Mi'kmaq. And the Mi'kmaq were, let's say, in dispute. This is about fisheries now. And so on the East Coast and the fisheries, the Mi'kmaq on the East Coast always said that we have traditional rights to the fisheries. Okay, they went to court, and the court said, yes, the treaty that you signed in the 1700s is still valid. And that means you have the right under the treaty to have a moderate livelihood. There's a lot of pushback against that by the people who are already in the industry, saying there's no room in the industry. So there was protests, there was fires, there was buildings were burnt down. The people who were essentially the fisher people of that area said there's no more room in the fisheries. Mi'kmaq, though you have the right, I'm sorry, but you can't fish here. So the Mi'kmaq did something a little different. So everybody who fishes here has to sell their catch to the wholesaler. one way or the other, it always goes to the wholesaler. So what the Mi'kmaq did is they built some partnerships and they bought the wholesaler in a $1 billion deal. So now everybody on the East Coast who didn't like the Mi'kmaq being there, who said, we don't think that you have a role to play now, they all now have to sell their catch to the Mi'kmaq who bought the wholesaler. That's interesting. How did they get the $1 billion to buy that? Why indigenous peoples? So the wholesaler, Clearwater, basically just said, well, we can sell to anybody, but the best way for us as a company to survive and thrive is to sell to the indigenous peoples on the East Coast because they have additional rights to the inshore fishery. And so it's better for us, it's a pure business decision to sell to this group. So you get the financing, you get the partners, and then you move forward from there. You say, well, that's kind of interesting. Oh my gosh. So let me just outline Canada. I didn't do that yet. So this is Canada. So the West Coast, north of 60 territories, provinces, Hudson's Bay, James Bay, Nunavut, coming down Labrador, into the Great Lakes. Sorry, there's the lake here. There's more Great Lakes, 5 Great Lakes, and then, of course, onto British Columbia. Sorry about Newfoundland and the East Coast, New Brunswick, Nova Scotia, PEI. So, I said, well, that's interesting. So what else is happening? $1 billion associated with it these days, within the last year. So there are some treaties here. So the indigenous peoples of this area here said, well, we signed treaties before Canada became a country in 1850. Robinson-Huron treaties and Robinson-Huron treaties. And the idea was there was a lot of resources in this territory. And so the treaties in Canada were there to move indigenous peoples around, to say that these are now the emerging and the Canadian nations' properties. So the treaties were signed here. And in these treaties back in 1850, they said, we'll give you an annuity, money each year. And that will go up with the resources that we take out of this area. It was ignored until recently and went to the court. And so now we're talking, well, there's 2 groups here who are negotiating. So one group just, we'll say 10 billion. They just settled their court cases. They said, well, we're going to court. They went in court. And the government always says, instead of going to court, because indigenous peoples win a lot in court, and these are big settlements, they say, we should negotiate. So let's negotiate and stay out of court. And so they just came to a $10 billion settlement for their treaties that were not adhered to. It never went up. And the idea was, well, they should have. What's that worth today? And so one group said, well, we'll settle for 10 billion. And the other group says, well, we're still in court because we think 10 billion is low. We think we get far more than $10 billion, so we stay in court. And so they're still negotiating now as to what that's going to be. But the floor is $10 billion. So that's another $1 billion that we're just kind of looking at, which is somewhat significant. The Human Rights Tribunal in Canada, and this was something to do with residential schools. And I can't talk too much about residential schools yet, but you should look into it if you don't know much about it. But the idea was residential schools were there. Indigenous children, I'll use the term indigenous all the time, indigenous children were taken away from their families, put in these schools with the idea to kill the Indian in the child. So to put them in, take them away from their family, destroy the culture, destroy the language, break up the families, with the idea that families would then assimilate back into the mainstream of society. And so there was a class action suit. What class action suit basically says, there's a group of people that go to court to enforce their rights. And so recently, with respect to, I'll go back to residential schools first, there was a recent settlement of 2.8 billion associated with those people, those children who went to residential schools in the daytime, so they didn't stay overnight. If you stayed overnight, that was a $5 billion settlement. With respect to children in the child welfare system, that is, children that are taken away, put into the state, and taken care of by the state, there was another class action suit which said they discriminated against Indigenous children because they didn't get the same rights and benefits as non-Indigenous children. So that went to court as well. And that class action suit was settled for $23 billion. Plus another $20 billion to change the system. So it's a lots and lots of billions of dollars. You say, okay, well, what else is going on? And it's a challenge I gave in my class. I said, well, in the report on business, it also talks about the oil and gas industry, which is primarily here in the prairies of British Columbia, Alberta. And that's our oil and gas products there. And so one of the major oil and gas producers basically went into partnership with 23 different groups of indigenous peoples. And they are looking at all the pipelines that are up here in northern northern Alberta. And they went to, and came into a deal, and that's worth $2 billion. Industry partnering with indigenous peoples. Why would they do that? And the answer is because it's just good business. If we want to succeed in business now, we know that we have to have indigenous partners to do that. It's not just here. It's not just here. It's not just here. It's not just here. It's up here. It's in Nunavut. Baffin Island is $2 billion worth of development going on over there. Let's see, Clean Water Settlement Act, $8 billion. The indigenous people said, on our reserves, our clean water, our drinking water, is not up to standard to those that are off reserve. It's discriminatory. They went to courts, and the court said, you're right. That's worth another $8 billion that gets distributed to indigenous people. And let's use that term, indigenous peoples. So the idea is that if you look at this and all the billions of dollars, and you say, that doesn't jive to what I know about indigenous peoples. I thought dispossessed, displaced, marginalized, isolated, colonized, socially, economically displaced from the mainstream society. What's going on here? And this is what I get a lot of times when I go to business and they say, what's going on here? Why all of a sudden this is happening? And it's not all of a sudden, but it is happening. And there's two words that you have to keep in mind when talking about indigenous peoples in Canada and the relationship with resources and with the Canadian state. That is speed and complexity. The speed of these developments that have occurred over the last 50 years have not occurred anywhere else in the world. And the complexity of these issues, it looks pretty simple here in my very modern interactive map here, but it's very, very complex to understand all these that are happening. I remember when I first went to university and I was talking to a colleague, this is way back in the dark ages, and he was talking about back in the 1970s and the 80s, and he said, I could read all the literature that on indigenous peoples that came out. And the reason was because there wasn't any. There was no literature, there was no books, there was nothing happening. Army books, indigenous graduates, there was a couple, you count them on one hand. And you could stay in touch with some of these issues, and it wasn't really much of a problem to do that. Now, professionals in the field, we look at this and we can't keep up with these developments. And neither can our students. And the reason is because all of these developments are happening so quickly that there is no literature on them yet. If you want to know about what's happening with the Haisla, what's happening on the West Coast, what's happening with all these billions of dollars of settlements, these billions of dollars and these billions of dollars, there is no academic literature yet. Because the speed at which this is occurring, by the time us academics get around to it and we publish our books and our articles, we're 5 years, maybe 6 years behind this field. And there's no way you can get this particular look or overall perspective because we look at them as isolated events. You might say, wow, residential school settlement, $5 billion, that's a lot. Day schools, maybe $2 billion. The clean water settlement came out of a reserve where Trent University is, I'll say right here, and the First Nation right beside Trent University, Curve Lake First Nation, was one of the original plaintiffs for the Clean Water Settlement Act. You might hear about that, but it's in isolation. You say, oh, I guess they got clean water. Oh, I guess they settled that. And you might see it once in a while, you might see it in the papers, and then you gloss over it, but you don't see the overall picture. And the overall picture is the one that I want to impress on everybody today, which is things are happening very quickly. and happening in Canada at a speed which, even in academia, we can't keep up with the literature and with the developments that are occurring. We were just talking last night, and I said, what other billions of dollars can we think of with respect to mining? Is mining, it doesn't matter what the natural resource is, it doesn't matter what the issues, but more billions and billions of dollars are associated with it. The other person that's here in this article, and again, it's the full page spread of a report on business that talks about CRECO. And talks about the Cree, who are up here in James Bay, and they're investing down here in Montreal, in Quebec, and they're real estate developers. So they're right downtown Montreal building a 27-story commercial property, and it's worth a couple of billions of dollars. And in the interview, they said, that's nothing. Wait till you see our next projects, they're big. This is our start. And the Cree in James Bay, and we'll get into why they, how they leverage to the position that they're at, would have billions of dollars in projects already. And so now they're into commercial real estate, just as commercial real estate down here for the Squamish, just as commercial real estate over here, and commercial real estate all across Canada. The other article that they talk about here, and again, it's Chief Charlene Gale. And Chief Charlene Gale, she heads the Major Projects Coalition. It's an organization out here in British Columbia. And the Major Projects Coalition is a group that says all of the Indigenous peoples in Canada are doing so many of these large mega projects that we should have one source where you could go to help out develop these mega projects, to get the financing, to get the legal talent, to get all the templates of how you do this, of how you put all these major projects together. Their portfolio of projects that they're working on is about $50 billion of all major projects across Canada, and supporting all those projects and how you actually put them all together. So the intersection between mega projects, big business, finance, and Indigenous peoples are all coming together. And you can see that when you just look at this kind of map, you say, my goodness, I had no idea that Indigenous peoples were controlling a lot of the development of resources in Canada. If you're mining in Canada and you don't have First Nations or Indigenous peoples as part of the approval or have them on board, and I'm not talking just IBAs, impact benefit agreements. Now we've kind of passed that where it's like IBAs are fine, that's great. Build a hockey, build an arena, build a school, buy, shirts for the kids and for sports. That's 5 years ago, 10 years ago. Now we want equity. And all these projects involve equity of Indigenous people saying, we'll take ownership. So CRECO down in Montreal, they own 95% of that commercial real estate. The Squamish own 90% of the real estate. And the Squamish down here, they said, well, who do we partner with in finance that knows how to do this kind of stuff, these big projects? And so they partnered with another First Nation in here, in the interior of British Columbia. And if you go to their reserve, their traditional territory, it's not a reserve anymore. It would be like downtown Santiago. You wouldn't notice because it's shopping malls, it's golf courses, it's high-end hotels, and you drive through and you think you're downtown Santiago. And it's a traditional territory of the West Bank First Nation, of Indigenous peoples. And they, if you want to look at their tax base, because they get all the taxes, it's their territory, it's their business that are on there, their tax base is about $1 billion, $1 billion plus. And so they partner with a First Nation here to say, well, we want to go into this business, you know how to do it, let's get together and develop these billions of dollars worth of projects. If you look at all the urban development that's occurring in Canada that are Indigenous owned and controlled, you might say as a group, that's the biggest landowner, single private landowner in Canada, and maybe one of the largest urban developers in Canada. And people don't see that because they can't connect the dots because we see them all in isolation and they're happening so quickly that it's hard to bring that to the forefront. How did that occur? So I'm going to give you, buckle up. We're going to go on a fast ride, and I'm going to be interactive, and I'm also going to try to do it on here. So explaining all of this is somewhat difficult sometimes because of the cognitive dissonance between what we know and what's happening. Because I can't believe it. If I just add that up, that's hundreds of billions of dollars. And that's what this article says. Well, if you start adding all this up, it's hundreds of billions of dollars. And that's why our economic future of Canada depends on this reconciliation with Indigenous people. If you want projects to go, if you want them to go fast, if you want to deal in the resources, whether it's fishing, logging, mining, it doesn't really matter. Indigenous peoples are going to be your partner one way or the other. Even on urban developments now, they don't need partners, they're just doing it on their own. So let's go into how this occurred. Goodbye, Canada. Come visit us if you haven't been here before. So I'm going to give you an Indigenous perspective of how we understand that relationship and how it occurred in Canada. Let's see, the click is not there. Aha. So that's just a summary of a lot when I go to businesses and they want to know what's going on. Why all of a sudden? Is this just a blip? Is it temporary? Is it a trend? Do we have to get ahead of it? And if so, how? Because we're hearing about all these things, residential schools, reconciliation, nation to nation, TRC, UNDRIP, FPIC, missing and murdered, consult and accommodate. We hear all these things, we don't know what they mean. We don't know whether or not it's something that we should pay attention to, and if so, how much attention should we pay to? Is it true that we have to have Indigenous partners now in order to succeed? And so I give them sort of a summary of Indigenous-Canadian relations, just different perspectives of what that looks like. Oh, that's a bad map. This one's much better. So when I was going through university, I was always asking the question of what's our understanding of Indigenous peoples, of our relationship between us and Canadian state, Canadian society. This is one of the elders. So I went to elders and traditional knowledge back in a time where nobody knew who elders were and traditional knowledge, and we didn't have that kind of understanding. And so this is one of the elders that I studied with at Trent University. His name is Jake Thomas. He's a Condole chief. You can tell by his horns and his feathers. And he's holding what's called gaswenta. It's called the two-row wampum. So when the Dutch came over, our immigration policies were very open at the time. We allowed anybody into the country. Our border patrols weren't that great. So when the Dutch came up into Haudenosaunee territory, into Mohawk territory, and we said, brand new people. So now we have two peoples on one land. What's our approach to these new immigrants who are coming to our territory? And our approach is illustrated by this wampum belt, which is the shells, which document, so this is the first international treaty between Indigenous peoples and Europeans when they arrived. And our approach as Haudenosaunee, as Iroquois people, are represented in that wampum belt. And our approach was, if we say Indigenous peoples and Western society, that our relationship between these newcomers and us, we recognize them as being nations. And we recognize them as being equals. So we are nations, you are nations, you have your way of doing things, we have our way of doing things. And what we do is we set up a nation-to-nation relationship. There's this middle space defines how we relate to one another forever. In the treaty, it was called as long as the grass grows and the sun shines and the rivers flow. That is, this is a relationship that we start now, which continues on to the end of time. Now we have to renew this relationship over time, and it's like two ships sailing down the river. We have our ship, you have yours. We interact, but we don't jump on the other ship, you don't jump on our ship, you don't take over ours, we don't take over yours. Nation to nation, equal relationship. That was our approach to our relationship with the newcomers coming to this land. And so I asked the elders and I said, well, how does this explain the Western perspective of this relationship? And they say, well, that's easy. The Western people, when they came over, that's the boat. So very Eurocentric, come over here, land in Canada, and then we have these two peoples on one land. The European Western perspective of all this is colonization, of course. We all know colonization. Colonization step one is erasure. So you erase that history. So step one of colonization is erase. So Indigenous peoples, they don't have a history now. So when I was in school, back here, and I go back, my question was always, so we go back to Europeans landing here in the Americas, landing here in Canada, what happened before they landed here? And so that's easy. We went back to Europe all the time, in Henry VIII and Napoleon and the wars that were on. What I mean is that in North America, where are the indigenous peoples in all this? There was no history. There was a fur trade. Yes, indigenous peoples were around. Yes, we got there. They played a role. And then all of a sudden, in the history of Canada, they're gone. So they got erased. I knew we were around. I'm Haudenosaunee. Our reserve just outside of Toronto, there's 10,000 people. We all know our history. But the question was always, but why is that never represented in this view of history? They said, well, I didn't know until later. That's colonization. Step one is erasure. You erase that history. It doesn't exist. Step two is replace. So you erase and then you replace. The idea then here was when Europeans arrived, then Indians were discovered. And we got a new name. We didn't call ourselves Indians. We were Haudenosaunee, and we had all different names, but Indians wasn't one of them. But now we got this term applied to us and we were discovered. And now we had legal existence. We came into being. But we had a lesser position than the mainstream society. We had lesser rights. In fact, we had no rights. What happened to all our rights to the land? Well, they just disappeared. They got erased. What happened to all of our institutions? Well, they got erased too. So we now occupy this lesser position in this manufactured historical narrative. And the idea was, well, Indians, they had a role in society, military, economic for a while, but then they got displaced to the margins of society. We got put on reserves, and we got put on reserves with the idea that at some point in time, we would reintegrate into the mainstream society. And Indians would cease to exist. It was a temporary measure. So we can erase people, but the people still exist. So this idea that this manufactured history was that, well, we put you on reserves, we have treaties, we have the Indian Act, they displace you to the margins of society, and the idea is you'll, at some point in time, see the light, you'll be civilized, you'll reintegrate back into the mainstream society, and what's referred to as the Indian problem will no longer exist. Residential schools were a part of that. When Indians were not reintegrating, said, well, we just have to tighten up the system a bit. So we introduced residential schools and we'll take away the kids. And then that'll break up the families. And when we break up the families and they lose their language, and we put them on these pieces of land that are worthless, and we give them government that'll never work. And we isolate them, they will then reintegrate back into the mainstream society, and then we won't have this temporary problem anymore. Of course, that didn't work. Indigenous people said they got placed on reserves and they did get isolated and they were marginalized and they were colonized and they did exist in the periphery of society, but they weren't reintegrating. This system continued on through to the present. So we have mainstream society and we have this society, this version of history also as well. If you remember, we also had that perspective of history, which Indigenous people say, we're still a nation, and we're still sovereign. Just because Western society doesn't recognize that that exists doesn't mean that we don't recognize that that still exists. Just because I don't know you have a sister doesn't mean she doesn't exist. She's still your sister, it's just I don't recognize she exists, but she's still there. Now, what most people don't see is what happened in 1970. We'll go to 1970 here. In 1970 was kind of an inflection point, in Canada at least. And the inflection point was the federal government for the very first time said, here's our policy towards Indigenous peoples. And our policy takes this view of history here. And it said, yes, you were displaced, and maybe we displaced you too far. And yes, you were marginalized, and maybe we shouldn't have marginalized you that much. And yes, we gave you some powers, because we have all the powers and you don't. Maybe we should give you some back, and maybe you should have your own governments and just increase those powers a bit. It was our federal government in 1969 who said, here's the solution to all this problem. And we can't have this exist because we have a group of people that are existing on the margins of society. So let's solve that problem. Let's get rid of the treaties. Let's get rid of the Indian Act. Let's get rid of all those things that keep Indigenous peoples apart, and then the system will collapse. And then this will disappear, and then the original social experiment will be a success. And we'll go together as a just society. Everybody be happy, and then we don't have to worry about all these treaties and Indigenous issues and all your rights. We'll just ignore it, water under the bridge, spill milk, all that kind of stuff. Let's not cry about it too much. There was a big, of course, pushback against that by Indigenous people, and they said, well, no, you can't get rid of these things. And said, well, but we have to in order to have equality. He said, no, we're looking for sovereignty. This was always our relationship with the Canadian state. What we're looking for is this, not this. And so we started building within the mainstream society and the institutional society, we started building a citizens plus. So this was referred to as a citizens minus. This was referred to as citizens plus, where Indigenous people said, we are not only citizens of Canada, but we have additional rights, not lesser rights. And we went to courts, and there was an explosion of activity in 1970. I don't know why this happened. And some of the elders that I talked to said, well, it's prophecy. This is what was supposed to happen in the seventh fire. We light that fire, Indigenous peoples would take their rightful place in Canadian society. So this explosion in 1970 onward has an incredible effect on what we talk about today. These are some of the elders, nutritional elders that I studied with. And we'll just go to, this is what we're going to talk about, that's far more interactive here. So in 1970 till now. So what happened from 1970 till now? And this is the one-page representation of history and all issues that occurred in one page since 1970 till now, from the perspective of building our Citizens Plus perspective within in Canada. So in 1970, I refer to this as the decade of firsts. And land rights and claims to Aboriginal and Indigenous rights were recognized, and the rights to land were recognized for the very first time. There were court cases which said, yes, Indigenous peoples actually do have rights. So maybe this version of history is not correct. Maybe this version of history is correct. And that started in the 1970s with the court system. And we went from zero recognition in 1970 to 10 years later. And I break this into 10-year blocks because things happen so quickly after that. It's almost like a quantum leap every decade. So we went from zero recognition of rights in 1970 until 1980, where we were included in the Constitution. And included in the Constitution were the rights of Indigenous peoples and our treaties. They're constitutional documents, which mean now they're higher than federal and provincial laws. We then went on to negotiate self-government, the inherent right, Royal Commission of Aboriginal Peoples, decade of negotiations, which accumulates essentially all of these. Let's see. So if we start in 1970, there's zero urban migration. Zero urban organizations. There are no political organizations. There is no movement whatsoever for Indigenous peoples. 1970, all that started, and it's cumulative throughout. That's why it keeps jumping every decade. So by the time we get to the inherent right policy and self-government and negotiations leading up to 2000s, the idea is now everything is being negotiated between Indigenous peoples and the mainstream Canadian society. Self-government, child's welfare, you name the issue, it's being negotiated. Land rights, self-government, comprehensive land claims, specific land claims. It's all now a decade of negotiations where the relationship between Indigenous and non-Indigenous is being negotiated pretty well on every front. Which leads to this new paradigm, I say, from 2010 till now, where now if you talk about the economy and resource development, then the three words that we talk about, economy, jobs, now, and Indigenous peoples, they're part of the equation. And that's what that article says, that if we look at the future of Canada, and we just look at it from a cumulative perspective, Indigenous peoples aren't part of it, then we are going to suffer as a nation. And people have said, why now? And I said, because that 50 years of development that have occurred. We had zero graduates in 1970. I was at First Nations University out in Saskatchewan. And between us and University of Regina, we might have had a couple thousand Indigenous students. There's another university just north in Saskatchewan, University of Saskatchewan. They had another couple thousand Indigenous students. There's colleges, and a college system within Saskatchewan. They had a couple thousand Indigenous students. So if you look at that, it's 6,000 Indigenous students in higher education. And it's because of those cumulative developments that have been occurring. So now when you look at universities across Canada, every university has an Indigenous program. They have Indigenous representation. Within the last 5 years, every university in Canada pretty well has either Indigenous professors or Indigenous administrators. Very anecdotal survey that we had, because we just know these people, you can't find the literature. We said, how many in the last 5 years Indigenous professors and administrators have been appointed? And it's like a couple hundred. And it shows that speed of development that has been occurring. And that speed is only increasing. So I point that out to most to say that if you think it's a blip, it's not. If you think it's leveling out, it's not. The trajectory is very clear. And that trajectory is that first map that I had of Canada. We look at Indigenous peoples in billions of dollars. Where did that come from? It came from that 50 years of development. And now, when we look at, like I said, talking about our economy, talking about Canada as a nation, and we look at mining, if you look at resource extraction, we look at any major projects, if you don't have Indigenous peoples involved now as equity partners, or at least involved and part of that process, then it's not going to move forward. It's going to be stuck. And a lot of times I get the comment back and say, well, which one of these histories is correct? Is it this one? Is it this one? Is it this one? Or is it that one? Like, which one is going to show us which one should we be adhering to? And I bring back this medicine circle. It's another Indigenous philosophy or an Indigenous paradigm with the idea that we're just giving different perspectives of history. So it's still one history, but there are different perspectives of history. It's like if you were to walk around a house. And if you're at the front of the house and you say, what's your perspective? And say, well, I can see the door, I can see how we get in, 2 windows. And if you walk around, there's another perspective on this side, there's another perspective from the back of the house. And at the back of the house, I say, what's your perspective? He goes, completely different than yours. And if I walk around that house again, I get 4 different perspectives at least. And the idea is there's no one correct perspective. They're all equally correct. It's just that it depends on where you are and the perspective that you're taking. So a lot of times when we look at Indigenous issues, we look at this perspective here. Displaced, marginalized, colonized, terrible social economic situation, a system that wasn't supposed to succeed and still is in existence today, a temporary system that was meant to be, don't worry about treaties, you're going to get rid of those treaties later. Well, we did get rid of the treaties, and that's what said that they had $1 billion deals with respect to treaties. And if you look at this perspective, and you say, well, it's a sovereignty nation-to-nation relationship, it means that it's that original relationship that we established at the point of contact that has continued through to today. So it depends on your perspective of which answers you come up with, but they're all equally the same. It's just going around that wheel and getting different perspectives. What happens a lot of times for, and I say my students as well, when you go into the literature, if you take this as your starting point, that's what you'll get back. And if you take, for example, that, well, Indigenous people are part of mainstream society, and you look at that perspective, you'll get that. Most people miss these 2 perspectives up here. Those ones are quite invisible still. And say, gee, I didn't know about that 50 years of development and the trend line that's occurring. I didn't know that it led every decade, one step on another step on another step, and there's quantum leap every decade to get us to this point right now. I didn't see any of that, and I didn't connect all the dots. And I certainly didn't know that at the time of contact that we have this nation-to-nation relationship based on sovereignty. So when I talk to people, especially those involved in extractive resources, and they want to know, is it a blip? Is this just a point in time that's going to pass and we don't have to worry about it again? And I said, well, look at the trend lines. If you think that's going anywhere but up, then you're misreading the trends. It's only going to increase, and it's only going to get more complicated, and speed is only increasing. 20 years ago, I could pretty well keep up with most of the literature and most of the development. 10 years ago, you have to start specializing. 5 years ago, I can't keep up. Ken and I were talking last night, two experts in the area. Can we keep up with all the developments that are occurring right now in Canada? No. We have a fairly good idea, and we can reach out and we can get all that information. But even get the data and the stats, as Ken did in his presentation yesterday, it's hard to get that data. You really have to dig. And that's what I challenge my students all the time, is that don't depend on the literature because it is 10 years behind. Impact benefit agreements, wonderful, 10 years behind. Where they're going right now is equity. So we're no longer passive observers to the developments that are going on in our land. We're equity partners. And not only that, but we're leveraging all that to be equity owners of all these developments across Canada. So that gives you, like I said, an overview. A very quick overview. I said, fast-talking lawyer here. I can talk a lot faster if I know my time is up. But again, that broad perspective, putting all those dots together and looking at the trends and how they impact and looking at to explain, that's why the billion, that's why all of these things are happening right now because of these developments. But it doesn't take away from the fact that that still exists as well. That gap is still there, but look at those developments and where they're taking us today, and it gives you a sense of where we're proceeding to the future. So thank you very much. It's been a pleasure. I think I'm still right on. I think I have 2 more minutes, but anyway, I'll give that up.
Thank you very much, Mark. I think we have time for a few questions. Great.
Thank you, I thought it was really, really interesting. Can I ask a couple of questions? Some of them are maybe harder. So the first is, are your chiefs elected or are they by birthright? The reason I would like to link that then a little bit towards like the accountability of non-elected public officials in the public space, especially in modern society. Then the second one is more around identity politics. How are you defining what Indigenous means as the population groups emerge and that initial identity kind of becomes diluted? Maybe that links to my own personal identity as originating from two separately colonized peoples, the Irish and the Lebanese, which is my ancestry, but I never think of myself as a colonized person at all. So I would like you to just maybe could you comment on that?
Sure.
Really interesting.
It depends on the lens.
Yeah.
So if you look at this system here, and again, we didn't get too far into it, but this would be the Indian Act system. So the Indian Act has a definition of who is an Indian, you have to apply, and then you get a little card that says, congratulations, you're an Indian, you got a number, you got a little ID, and that's the system here where the chiefs are elected. In this system up here, the traditional system, the chiefs are hereditary. So you might hear, for example, the pipeline debates on the West Coast, and they say, well, we have the support of 90% of the First Nations for that pipeline. And then you say other people, the other chiefs, the hereditary chiefs are saying, yeah, but you didn't get our approval. And the company said, well, wait a minute, we already got the chiefs. And they said, no, we're the hereditary chiefs. So we go back in this. We did give up our forms of government. You replaced them and gave us another form, but you didn't get rid of the system that still exists today. So you might say with Wet'suwet'en, Wet'suwet'en, and the pipeline is going through, and they said, well, the chiefs are protesting. That's hereditary chiefs. And they said, well, we weren't consulted. You consulted these chiefs here. With respect to the different groups, I'm using one term, indigenous, but that doesn't cover all of these developments here. There's First Nations, there's Métis, there's off reserve, on reserve. You have national organizations for women, you have national organizations for urban Indians. And for example, in the north, in the Inuit, you have four different regions of Inuit, and they would define all differently. So it's a very, very, like I said, speed and complexity. The speed that gets that trend, complexity is trying to understand all of the different identities that go into that. For example, I wouldn't say that I am from the Six Nations Reserve. We say Six Nations Territory, Haudenosaunee Territory. We're part of the Confederacy. We're Ongwe-Omwe. We're traditional, and we identify ourselves from this. It's true we have a reserve, but we don't identify with that. But they're all still part of the equation of how we identify ourselves in the world. Very, very complex. Yeah.
You were speaking about the shift in policy in the 1970s or in the 1970s. Why did it happen then, or what motivated that?
Again, I get that question a lot when I say, well, what happened in 1970? Because it occurred everywhere, in every area. So, for example, Indigenous artists came out and they said, well, we're not primitive art. We have our own form of Indigenous art. So a group of 7 artists got together and said, we define our own art from now on. You had elders coming out in 1970 and saying, yeah, we're not going to hide our traditional knowledge system anymore. That has to be public. And you had political organizations starting at national, provincial, local. You had all this explosion of political organizations. You had legal, for example, the first time that it went to court, and said, now courts get involved. That's the first time that happened in the 1970s. So legally, and courts get involved on this. Every spectrum of society and interaction between exploded in the 1970s. And I go back and I say, why is that exactly? Now, what happened in the 1970s? Well, some people say it's a 69 white paper. The federal government came in and said, we had no rights. And that was a catalyst. And that was why it happened. Others say, well, it was the turbulent 60s after World War II. And the reforms that came on from World War II. And then in the 60s, and the freedom and liberalism. And so there's all these kind of definitions. The one I like the best is, like I said, from the traditional elders, where they said it's prophecy. It's called sort of the 7 fires, that we're at the end of 7 fires, where Indigenous people now come out and they take their true After a dark period, now we light that seventh fire, which is the idea that indigenous peoples now take their rightful place within society, and others start following our ways of looking at the environment, for example, how we look at environmental issues, how we look at development and environment. And so it was foretold, and then we're just entering that era. So there's a lot of different explanations, but all of that in those 50 years has not occurred anywhere else around the world. So if you look at Fennoscandia, if you look at Australia, New Zealand, if you look at other South America, like the global South, that development hasn't occurred, or if it is occurring, it's at a different stage. So we look at lithium mining now, that was back in the 1970s when we looked at mega projects when oil was discovered in the north, or hydro projects were being developed. Indigenous people weren't visible. They weren't a part of the equation. And 50 years later, like I said, we are not only part of the equation, but if we're not equity and components of that equation, then it's probably not going to go forward. So I don't know exactly why that catalyst in the 70s in Canada and why the speed of that development, but you have to remember, back in the 70s, only 3% of the population. So it's a very, very small percent of the population, no formal education, and driving that development every single decade. To go from zero recognition to constitutional recognition in 10 years is a major feat. And it doesn't happen too often. And it happened in Canada. And so when I go back and I ask those who were involved, they said, yeah, we just keep pushing and pushing and pushing. And that was, like I said, what we're trying to do is build the connections back into supporting that nation-to-nation relationship that was originally there. It's always been there, it never went away. We're just pushing for it, and we've been more successful than others. Okay.
Thank you very much, Mark.
Thank you.
I invite you to speak with Mark at the coffee break. We will now have a short coffee break and come back for the second presentation. So, thank you. Okay. Thank you. So our next presenter is Pilar Parada, that is biochemical, and she also holds a PhD in molecular biology from Universidad Autónoma Madrid in Spain. She is presently director of the Biotechnology Center at the Universidad Andre Bello in Chile. Previously, she was involved in BioSigma, which was a company dependent from Codelco, Chile, and she has been also in a Fraunhofer Center of Excellence. Her presentation is about biomining, and the title of the presentation is Circular Biomining for Global Recovery, an Opportunity for Tailing Reprocessing.
I hope you can hear me without the microphone because I like to walk around. And if you feel that you're not getting what I say, please raise your hand. I can explain because it's much more technical than the previous presentation, the wonderful presentation from Mark. But I would like to be also interactive. So if you have any question, please raise your hand. I want to start by raising the thing that today we are facing a crisis, a climate crisis. We have had in Europe and in USA last summer, 56.7 degrees in the Valley of the Death in USA, so really high temperature. In Spain, we have had this drought that is taking away all the agriculture activity from the south of Spain, and the income with this also is slowing down. We have this island value that is already organizing the immigration to Australia because it's going to disappear because of the raising of the water. So, and also in Mexico, we have had this flooding. So we look around and we see this climate crisis that is really hitting us. And actually, today is finishing the COP28. And we have heard many things that the president of the COP28 have said that there is no science behind the climate change and the changing of the fossil source. Okay, so it's really shocking to me to hear these kind of things because we have been suffering this crisis during this summer, and probably in this south part of the world, we will suffer it too during next summer. So the question is, we are aware that the fossil fuel combustion is a major contributor to the human-induced climate change. How do we change this? How can we move forward by replacing this fossil fuel source? We see that the fossil fuel source are the main source for the energy production and also for the transportation. Okay, so if we look around, we see many other uses of the fossil fuel, but mainly the main uses are the energy production and the transportation. So actually, we have something very clear to tackle. Okay, and let me just make a parenthesis, because And it's very important for the rest of the presentation to understand what is the battery. And why do I put this slide here? Because to move forward to clean energy, we need to use this kind of devices for better, okay? And battery is mainly, it's an energy production, it's an energy production device, okay? So plays a key role in transition to cleaner and more sustainable energy system. And the idea is that you will have this as the main obstacle today for moving into a cleaner world, okay? And what is a battery here? And in a very, very simple diagram, because you have many types of battery, but mainly you will have two electrodes, one anode, that is the negative piece of metal, and then you have a cathode, that is the positive piece of metal, and you will have the flow of electrons from one side to the other, and this is separated by an electrolyte membrane, a separator, yeah, so that you don't have a shortcut, okay, a circuit shortcut, and then you will have when you have a car, for example, you will use this energy device and it will start flowing the electrons and producing energy, okay? So producing energy, there I put a bulb, but it can be the car, the energy of the car, okay? And then when you plug in the car, then all the electrons that were there will come back to the cathode, okay? So charge, and this charge when you use the car, and charge, again, all the electrons will come to the original place, okay? So this is the main thing how a battery works. And very interesting is, and this is part of the main topic today, why cobalt, okay? Because you have plenty of different types of batteries that are rechargeable, and some ones that are not rechargeable. For example, the ones that you use in the electronic devices, you will throw it away because they are not rechargeable. But in the case of the cars, you will recharge by plugging in, okay? So why cobalt? Cobalt and this lithium cobalt, because mainly all of the batteries today for cars has lithium. There is no other way today than lithium, because it's a very reliable metal and very can store a lot of electrons in a small amount of piece of material. Okay, and the cobalt will be part of the cathode, okay? But this is, you can see here the many type of lithium, cobalt, magnesium, and oxide that are being tested. And the idea of using cobalt is mainly because it is, as I said, high compacted density, so can store a lot of electrons there, so a lot of energy. And also energy density and excellent cycle life also. It's very thermal stability, it has a lot of stability, so it won't warm too much or explode, okay? So the idea of using cobalt is mainly because it has this, you can see here that it has a thermal stability, a capacity retention, and a discharge capacity that is also helping in the batteries of the cars. Okay, so that's why cobalt today is very interesting in terms of technical usage in cars, in electromobility, I would say. So, of course, the significant increase of the demand for cobalt, its use in the electromobility, makes it more scarce. Okay, and the main producer today of cobalt in the world is the Democratic Republic of Congo, where there's a lot of arguing there because of the way it is extracted. there are many problems regarding worker exploitation, child labor, and also toxic pollution. So you can see here, very artisan way of extracting copper, but they are extracting 145,000 tons a year. So they are having a lot of cobalt there. And in Indonesia, you can see here, it's the second world producer with only 10,000 tons a year. Here you can see it there. Here you can see the graph. So 70% of the Republic of Congo is producing the cobalt of the world, okay? And then Indonesia, Russia, Australia, etc. So, and here is a big opportunity for Chile. Probably you don't know, but Chile, until the Second World War, was the second producer of cobalt. The main, we exported almost all the cobalt to Germany, and because of the Second World War, we stopped selling it because it was mainly for making weapons, okay? So we stopped producing cobalt, but we still are the first producers of copper in the world. And copper and cobalt is extracted together with copper and nickel. So we still have a lot of cobalt in our tailings, okay? And that's why I say, why don't we take a look into these tailings that today is waste material mainly, okay? And if we take a look on these tailings, and this was, this Corfu agency, funding agency, Chilean agency from the economy ministry, they asked for a study, and in this study, Dr. Ryan Townley worked with his team from University of Chile to characterize the tailings that are today in Chile. And there they find that we have 764 tailings, that most of them are abandoned, okay? And in these deposits that Serna Geomin, which is also a geological service of the Ministry of the government, is having this report of these 764 tailings. And they saw that in all of the tailings that are in the north of Chile, because of the geology of this tailing, there's a lot of cobalt present. So my position here, and this is why we have had this attention from the TV and radio and many people, because we said, okay, we think that Chile can easily position as the second producer of cobalt in the world again. And unfortunately, you don't even have to do mining because it's there in the tailing. So it would be more cheaper. And why is that? I will show you here. 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 Oh, sorry. There. We have here in the total addressable market in the world of the cobalt, it's 186,000. As I already showed you, 70% of those tons are produced by the Democratic Republic of Congo. And that is, the market is 6,510 millions a year, okay? And what we have in Chile regarding the potential only, because of this study that I show you, is that we can go rapidly to 22 million tons of cobalt a year. So that would be a market of $770 million dollars a year for Chile, which is really something very interesting. It's comparable in some way to copper, so it's not little. And if we go only producing 70% of those, we would rapidly go to these 15,000 million tons a year. So with that, and with this graphic, we can say that easily we can go to the second place, okay? And why not to do it? We have it there. Okay, there's also another thing, because here we have only the analyze the economic topic of taking away the coal, but there is also an environmental and a social other story with the Chile opportunity. And it's if we see, for example, there you have a photo of what happened in Brazil, in Vale. We have a big issue there, big flooding, because of one tailing that was destabilized because of the activity, the natural activity of bacteria that are degrading a part of this tailing and making it more unstable. And this is why it came down, and many people were died because of this disaster. Okay. And also we have places like Andacollo and some other places in Chile. This is a photo from Andacollo, that you have a tiny town here and a big tailing just behind. So there is a good thing that if you reprocess this and can move, because you don't have to invest in mining, as I said, because it's already there. Okay? So the idea of this is that you take away the copper, you reprocess the tailing, you get value, and you get value also for the people living there, and not only threatening like is today. Okay. So, and how we propose this solution to be done? Okay. Well, Chile has a long story of violating of copper, as you probably know, and you don't know why I tell you. Since 1980, actually, were the first activities of bioleaching. And I have the honor to be part of this history because I was the general manager of BioSigma, as Jax already told you. And in BioSigma, in Ramiro Tomic, we built this plant of bacterial production. So these are all bacteria that are, I would say, eating the mining reserves to take away the copper and to leave the copper in solution, because they use the iron and the sulfur as their source of energy. Okay. So this is right now, today, working in Ramiro Tomic, in the north of Chile, next to Calama, up to the mountain. And it's extracting copper from the dams, okay? But it also can be done for primary ores. So ores that are being taken, because now it's for tailing also, but it also can be done in primary ores. And the thing with bioleaching is that it consumes 6 times less water than the traditional flotation and concentration process for extracting copper. So really, in terms today, it's more important than 10 years ago, because we have this water scarcity, especially in the north of our country. So what we proposed is actually another very important thing is that bioleaching of copper is carried out in a closed circuit. So the water is being used, can be reused several times, okay? So, and also a very important thing is that it's not causing any toxic emission. So it's not harmful for workers that are being there extracting the copper. As, for example, the chloride gas, because now there's a big trend, especially in Chile, of using high chloride, for example, like seawater, that you have a lot of chloride there, but also putting more chloride to go up to 100 grams per liter of chloride. But this chloride is producing gases, toxic gases that are very harmful for the health of the workers. And also another very important thing is that the bacteria, this type of bacteria, will use the the ferrous iron as their source of energy. So as they are oxidizing this iron 2, they will produce iron 3 that is an oxidizer of the minerals. So actually it will be a closed circuit with the bacteria, you know. So this is very interesting because what we propose here for cobalt, and as I told to Jack, we're just starting this project, so I will not show you, I will not spoil the story because we still don't have final results. We're just working on it. But what we propose is to make an adaptation of the biology of copper that we already know for decades to this cobaltiferous pyrite, okay? And we have done this joint venture between Universidad del Desarrollo, where I am now, founder of System Biotechnology, and the MTC, the Advanced Mining Technology Center of Universidad de Chile. And we are both centers together working on this project. It's a 4-year project, together with a mining company called Pucobre, that is having tailings in the north of Chile. And we will be ending this story with a pilot plant for producing cobalt. The idea is that this new technology that we are going to develop, it's based on these circular economy principles, and also would be creating value for the communities that are in the north of Chile, and also for the country, because it's another metal. Today we have the lithium, the copper, and also we will have the cobalt. So we have this triad for making batteries, okay? So maybe this is what I have to say today. We want to, because probably you have heard that people refer to the cobalt as a blue gold. We want to go from the blue gold to the green cobalt. So if you have any questions, please feel free to ask me. Yeah.
Thank you for your presentation. I was wondering, because you're saying these tailing valves already exist, is it possible to do this extraction on the existing footprint of the site? Could it be like a cell that kind of moves with the operation, so that you're not increasing the environmental footprint? Is that, or what do you envision?
Yeah, thank you very much for your question, because this has two sides, no? Because sometimes when we say how not to increase the footprinting, what we have actually concluded is that the best way not to increase the footprinting is not to do anything. Because when you do something, of course, you will do some footprinting, you know. So here the good thing is to compare which is the footprinting of making it conventionally versus making it with the bioleaching. And as I said, the good thing of bioleaching is that you are using a lot less water. And also, I didn't say it, but it's very much energy less consumer than normal or conventional processes that are crushing the minerals, you know, those things that are consuming a lot of energy. So of course, I'm convinced this would be, and that's why we planned to do it into a circular bioeconomy concept, you know, so that you can, of course, use the tailing that is there and use it in a way that it's creating value, and this value can be, of course, part for the company, part for the state because of the taxes, and of course for the communities that are there. There are many communities in the north of Chile that are actually threatened by the tailings existence, and many of these tailings are abandoned because now there's a law in Chile that you are obligated to take care of your tailings. But some years ago, there were no law. So most of these more than 764 tailings are abandoned. So this is a threat that is existing today for many communities. And the government should take care of this, but how can the government should take care of this with no money for doing that? So this is a good idea because you will extract value with the cobalt. We think and we propose to the state of Chile, because we think that they will get money from the extraction of cobalt and then they can take care of these tailings. So that's why we think it's a very green project.
I wondered, I'm sorry if I missed it, but worldwide is biorefining of cobalt or remining from tailings happening now?
Yes, it's happening. I mean, for example, the Democratic Republic of Congo is producing it manually. They are taking away the cobalt because it's very concentrated. You can see the blue gold there, But actually what they do is to send it to China. And China is today the most important refinery of cobalt in the world. And they are also producing a lot of batteries for electromobility. So, but this is something that we also have discussed with the people or with the government, because today we have no industry of battery manufactured in South America. And that would be a great idea, because you have nickel in Brazil, you have copper in Chile, lithium in Chile, and we can have copper. So if we can put a spot in South America for making batteries, and then the car industry will also, flourish. And then you will have a less footprinting, because you will not have to move from China. Imagine Republic of Democratic of Congo to China, then the China distributing the cars all over the world. So how can we tackle this problem of climate change? And that's why I started by that, is to think globally, but locally, producing local, producing batteries, producing, cars. Yeah.
So going back to that slide around the environmental and social benefits of the bioleaching process that you're proposing, maybe it's, another part of your project that you're considering, but I'm wondering, let's say you develop this bioleaching process and are able to commercialize it. Is there talk about once you remove those tailing piles to restore the land to some natural habitat to stabilize that slope? Is there talk about that as part of the process as well?
Yeah, that's a great question. I would like to say yes, but unfortunately 4 years is too short time. We were discussing with Doug actually that it's kind of very difficult in countries like Chile to have a roadmap, a long-term roadmap. I would like to have that. Because in that situation with a long-time roadmap, you can imagine some other uses of the tailings, because once we get away the cobalt, we will still have some waste land there. So what to do with that? And today we have a lot of, emerging technologies like using these tailings for making bricks, for different kind of applications. And we would like to work together with those people, but of course you need a lot of money to invest there, a lot of money. And actually we are now in Universidad del Desarrollo, we are part of a project that is gathering together students that are having this kind of ideas, that are in the concept of circular economy, so that we can work together. I think today, regarding what this president of Abu Dhabi said about there's no science behind replacing the fossil, I think that today we have to think on working together, collaborating, so that we can have these different initiatives together for a better world, This is the only thing that I can imagine that we can move forward from this crisis situation today. So thank you for your questions. Yeah?
Next quick question, is the cobalt present as a sulfide mineral? And if so, then bacteria are in those sulfide mineral?
Sorry again?
Is the cobalt present as a sulfide?
Yes. Yeah, this is very interesting because actually the study that I show you that Dr. Brian Townley, which actually he's the co-director with me of the project, they found that cobalt is present together, is appearing with the pyrite. So pyrite is iron and sulfur, mainly. Okay, so it's like it's absorbed to the surface of the pyrite. So that's very interesting because then you can go directly to those kind of tailings that are having more pyrite, and then you will find more cobalt.
What's the pyrite content of those tanks?
Yeah, this is also very interesting because it depends geologically on the place. And actually in the north of Chile, actually in the regions of Atacama and Coquimbo, there's a big geological, fire? Yeah, it's a place geologically like that is having a lot of pyrite, and it's IOCG, so iron, ore, copper, and gold. And this kind of mineral is having a lot of pyrite, so then it will be having also a lot of cobalt. So it's kind of easy peasy. Yeah. Yeah.
Why are you looking only on old tailings and not on the tailings we're producing now? And that's, I think that's a big question, because if you look at the processes, we are just recovering copper, in some cases molybdenum, but we don't put any effort on looking at other elements that may be present, for instance, rare earth and
Actually, it's not that we're not looking at it. We think that it's more easy to go first to the tailings because are there, and as I said, you don't have to invest more money because on mining, I mean. But of course, we're very interested in fresh tailings that are coming away together with the copper extraction. And today, actually this Thursday, we will go to see a fresh extraction of this scavenger tail that is it's getting away from the copper extraction, and we will characterize how much cobalt is in there, because we think this is another side of the business model that we have to tackle too. But we will move forward first with the tailings, and then with the tailings, because we think that it has this social thing, that is there, is a threatened, it can be destabilized. Actually, the presence of pyrite is the reason of the destabilization of the tailings, because with the water of the the rain in the winter, or also in the summer in the north of Chile, with the rain weather, you can dissolve this pyrite, and then you will destabilize the tailings. So that's why we think it's a critical and threatened today it's a social problem. So that's why we go first to this, but after we tackle this, we can go also with the other fresh tailings.
How do you recover the cobalt from the solution?
That's part of the project too, because we have several ways and several projects, several products also, because it can be obtained as hydroxide or as a sulfide. So we're testing also this. Yeah.
So with all the different tailings, surely, like you were talking about, they have very different compositions, some of them.
does that present a problem for the bacteria when you're going from site to site? Does that mean that you have to make different generations of the bacteria?
Yeah.
Are they very pH and temperature sensitive in terms of on site? And I guess the last question was, you had the 22,000 megatons per year production. Based on the current tailings, how long does that go for before you run it?
Thank you very much for your question, because as I am biochemist, I love that question. Actually, the bacterial problem is actually that they can be sensible to some toxic elements. And one of these toxic elements can be chloride, for example. That's why I don't like the chloride system, of course. But also some other high content, for example, that you were saying about rare earths. Some rare earths can be very toxic for bacteria. So the magic of this story is how to make them strong, how to, and that's why I put adaptation, because normally the best way to look for stronger bacteria is to go directly to the place where you can extract the copper, because many people go in a fancy tours taking bacteria from geysers, from different places around the world to look for good and strong bacteria. No, our idea is to go directly to the place where you will treat, in this case, where you have the cobalt. So this is part of I'm telling you the secret. Yeah, this is part of the development actually, that we are making the bacteria more adapted to the minerals that we are testing. And exactly that's the point, because we take different samples of different tailings that are representative of these differences that we have here in Chile. And then we test different types of bacteria. So we call it the dream team, because it's not only one bacteria, but many bacteria that can face better and dissolve better the pyrite. Actually, I have to say that the dissolution of pyrite is a very easy thing for bacteria, because they use iron and sulfur, the main components of the pyrite. Yeah.
Mi pregunta va un poco más relacionada a la técnica extractiva que van a utilizar. Tengo entendido que ya el uso de bacillos ferróxidas ha incrementado bastante la productividad por cuanto regenera el consumo de bacillos ferrosos a carbón férreo.
Yeah.
Pero desde el punto de vista ya extractivo, ¿se está pensando en algún tipo de sistema de lixiviación intensiva en la lixiviación in situ, con pilas?
¿Cuál es tu nombre?
Gonzalo.
Gonzalo made a very interesting question. What is the way that we will extract in terms of reactors or heaps or whatever we would do for taking away the cobalt using the bacteria? Actually, I didn't show here, but what we used for copper was actually heaps, big heaps. And the idea of the heaps, I like it best than the bioreactors for two reasons. Because I show you a photo of a bioreactor, but this is kind of tricky, this one. This is a 35 cubic meter bioreactor, but this is only for growing bacteria, okay? This is a continuous reactor that is growing bacteria, but after this, we go through this piping and we irrigate the heaps, okay? So you get the heaps, a heap is a big hill, mainly, and you will irrigate it on the top, and you will get it in the base, the dissolution of the copper, in the case of copper. And in the case of cobalt, we want to test the same. And why I like the heaps? It's because of the question of the toxicity. Because in a heap, you will have the dissolution and you will be moving forward until the base and you will take away, the cobalt in this case. But in a bioreactor, you are concentrating while you are dissolving the cobalt. So higher concentration of anything can be more toxic for bacteria. But anyhow, we will test different types because we have some things that we call content bioreactor. That is mainly a heap, but we are making some, passes again and again and again until we have some concentration that is toxic or not toxic for bacteria, so they can die. So and then we take away, So we will. This is actually a very, very interesting way of, because the idea is to move to Pucobre on site. So we will do it on site, not at laboratory level. We will only the laboratory level we will take 1.5 years, and the rest of the 4 years will be on site. And the idea is to test these kind of things.
Precisamente mi pregunta iba referida a que uno de los puntos a favor que tiene el tratamiento de estos relaves es que nos vamos a ahorrar todo el proceso de extracción y combustión del mineral para la liberación de la partícula mineralizada. Pero quizás la pregunta iba enfocada a la estabilidad mecánica de la pila, por cuanto el punto a favor de que el mineral ya se puede encontrar liberado. La estructura mecánica propiamente tal de la pila podría generar un problema en términos de la irrigación.
Yes.
¿Tiene pensado quizás alguna especie de proceso de aglomeración?
Yes, absolutely. Yeah, he knows. Yeah. Actually, the way we construct the heaps is with agglomeration, because the size of the tailing is very, very small. So if you imagine when you go to the seaside and you make a heap of the sand, then it will float. If you put water on it, it will float down and will be a disaster, The idea here is to agglomerate, so to make this glomerulus like, 3-4 inches, and then to make the heap with those glomerulus, and then to irrigate. And of course, all of this is made by the people that knows, which is not me, because I'm a biochemist, not geologist, but Brian and his team, he knows very well, and they have these models to simulate how much water or irrigation you can put for not to have this float. Thank you, Gonzalo. I like that you make a lot of questions.
Okay, thank you very much. And now we will move to the two parallel technical sessions, session 7 and session 8. Session 8 will take place in this room. 7 in this room, sorry. And session 8 in the other room.
Okay, we're good? We're good? We're good? Okay, I think we're good to start. Greetings and welcome. In case you're wondering, this is session 7 on water, quantity, quality, and conservation, and the importance of community involvement. Actually, all the presenters today, my name is Asaf Zohar from Trent University. Can I just have an indication of English-only speakers? English-only speakers? I have a suggestion. Can I have you folks move over here? Because we have a couple of presenters that will present in Spanish, and we have some folks that will help with simultaneous translation. So if I could just English, you guys stay here. You're not going to comply?
I'm just trying to get it all down.
Okay, it's all good. So if you could just move a little closer here, and Moisa, I'll ask somebody to help over here, and she's just left. She'll be here in a minute.
I can do the English Spanish translation.
Okay, so I'm just wondering, instead of doing it from the front, we only have 5 English speakers.
Yeah.
If you could stand with them and just kind of in the background talk, is that okay?
Yeah. Yeah.
Does that work?
Yeah.
Is that good for you?
But speak slowly. Sí, sí, okay.
Okay.
Sí, más adelante. ¿Cómo te sientes?
If you wish to speak English, it's fine. It's fine. We are your guests here. You speak in any language. It's all good. It's all good. So we've got 4 sessions that will take between 10 and 12 minutes. And then the fun starts in terms of the questions. I'm super excited because this is about community engagement and involvement. And to me, one of the most important sessions we can have in a conference like this. We will start with Felipe Olivares, who is going to talk about Voluntarios por el Agua, Volunteers for Water, a community science project in the Maipo Valley in Chile. Then we will have Consuela Martinez Fontaine, who will discuss working with communities in coastal watersheds between Ligua and Aconcagua river watersheds. Then Camila Sandoval Ibarra will describe adaptation strategies to address water scarcity while conserving the cultural heritage of an indigenous community in northern Chile. And finally, Melissa Correa will give insights into her engagement with the Lican Antay community of Caspana, highlighting 2 interrelated processes, cultural and water resource mapping in empowering indigenous communities. So welcome all.
The Maipo River, 200 kilometers in 30,000 kilometers, 70% of drinking water for Santiago, 87% graphite and snow origin, most turbid river in Chile. In the face of that, we come together for protection, awakening water watcher. This project has been supported with the following association companies and friendly universities, for example, Comité Ambiental, Cajón del Maipo, Por Otras Aguas, Universidad del Desarrollo, etc. What is doing Missouri? The first Sunday of every month at 10 a.m. 14th each with their instrument kits. The points in El Canelo, El Manzano, San Alfonso, San Gabriel, and Baños Morales. Photographies, the analysis of the river Maipo. The mediation voluntaries. What do we measure? And there are 4 kits with multi-parameter, pH, temperature, conductivity, dissolved solid, salinity, oxidative potential, hardness, titration, bacterial, total coliform, and E. coli. Paper 15 parameters, for example, chlorine, bromine, iron, lead, copper, fluorine, nitrate, alkalinity, pH, etc. Activity tool in the department. There is security instrument and one dissolved oxygen instrument too. Share between chest. Repetitive photo, Maipo Colorado Conference, April 2022, Julio 2022, September 2023. The volunteers. Repetitive photo, Volcan Morado Conference, December 2022, November 2023. An orchestra running in parallel with coordination and consistency. In general, voluntaries, photographies, and distintos como tiempos o meses. Outreach activities and environmental and community files. Charlas en general en congresos, entre otros. How to say volunteer dies, standardization and consistency in data analysis, graph, registro data, etc. How to job mode, remote change and 80 points, videos, 30 graph, calibration every 3 months, replicability from first year reports, April 2022, March 2023, for example, parameters, salinity, conductivity, entre otros. How to get the message across with colors and showing the cyclical nature of the season. From first year's report, April 2022, March 2023, download is the hair and link, the stream flow and dissolved solid in 4 stations of micro. Parameters, dimension, temperatura, conductivity, ORP, entre otros. Project Win Studies, DC and Practicals, Diego Gangas, Ucatónica Temuco, Data, California, Santa Bárbara, Medition in River Maipo, Práctica Integral de Chile, Medition in the Maipo, Students UDD, Comparison between DGA and WA station, satellite images to see change, vegetation, snow, river size, year with year. Dirección General de Aguas, National Water Agency. Juan Pablo, Venezuela Católica, glass blowing and dirty breathing and calibration with milk, and orange, quiz and the field. 32 calibration range 30 to 380. Además de sí, for Social Environmental Justice Book, in 2022, they designate Urloyo, suggestion for river safety measures, repetitive photo support, outreach materials, stand organization and volunteer training, layered watershed maps, dirty map, booklet for breathing measurements. Scientific mapping of the Maipo River Basin. April 2023, 15 people attended the University UDD O'Higgins, Fundeso, in San Jose de Maipo. Talks and stands from local activities and scientific research. Join the CAMPA network. American Continental Network for Participatory Community Water Monitoring. We incorporation from June 2023. We were at the first meeting November 2023 in Villarrica. We exchanged water measurement and knowledge with other members from different countries. We learning how macroinvertebrates and microinvertebrates are measured to access the health of water bodies. Inauguration of a water monitoring point Monte Alto. In December, we inaugurated a MEP monitoring point. Quality parameters such as pH, conductivity, ORP, among others, were measured with the multi-parameters with them with Mapuche communities for monitoring. First meeting with Seremi and Medio Ambiente for whole beautiful project. Mapuche Ancestral National Protection Point Puente Alto. As part of the home visit projects in September, I'm involved in reforestation and conservation activities. Photo concrete for Minor. Futuros projects, el project Despertar el Río, Patagonia, Chile, project with storytelling about the source and journey of the waters of the Maipo River. Hopefully, a 2-year report due in April 2024 start to write of the data with scientific rigor and comparison with regional and national standards, verified of STEM, continue to join international network like Red Campaign. Much local interest in drinking water testing, both with licensed laboratories, charging $200 for a full analysis. It is difficult. Question about our future project without a definite large. Conclusion. For example, environmental education and awareness raising has been the biggest with lots of data analysis for volunteers and comparison with the NGA. Volunteers start to notice changes ahead to know the river. The effect it can have in Santiago resident is invaluable to spread the word about protection. Activists begging to understand data and notice changes, speak up and share their knowledge. How can we use the data for policy development advocates for protection? Join this very first Sunday of the month at 10 a.m. in 5 points along the Cajón de Maipo. Thanks to the more than 50 volunteers.
Voy a la consulta. ¿Cómo reciben las demás partes interesadas de la cuenca estos mensajes de los voluntarios? O sea, ¿cómo influye en la toma de decisiones para, por ejemplo, el sector público, el sector privado, todos estos resultados que se van entregando? ¿Cómo este gran trabajo que hacen los voluntarios incide en las políticas públicas y en la actuación privada y en todo el contexto, digamos? Sí, me puede.
Mira, en general, Voluntarios por el Agua nació de medición simplemente del río y hoy en día estamos avanzando en la parte de poder entregar primero el primer informe de la data respectiva. Hoy en día nos hemos hecho conocidos con la comunidad, con diferentes asociaciones, y también el sector privado no tiene mucho contacto, pero sí nuestra idea es seguir como monitoreando y conocer el río finalmente. En sí la comunidad ha tomado muy bien este proyecto, ya que ha aprendido bastante sobre ciencia ciudadana, ha aprendido bastante sobre cómo el río va en la temporalidad del año, y así va influyendo bastante en conocimiento científico en general. Conocer más su hábitat en el fondo, y también creo que deberíamos acercarnos como un primer hito o un primer eslabón a la parte privada o a la parte de normativa. Cuando hay un problema, por ejemplo, en los ríos, sería como un primer eslabón para que después el ente público como el EGA o Ceremi vayan a monitorear respectivamente. Creo que es importante como ese nexo conjunto.
¿Puedo decir algo? ¿Traduzco algo? Sí.
Can you summarize
yeah.
a little bit?
So they were asking how does the measurements kind of translate to policy or to kind of informing the government or other agencies? It's something that hasn't been done so much so far, but we're kind of still gathering the baseline data. But the idea is if we start to note something anomalous, that we can kind of inform them and that they can go and take a measurement. So if we're keeping this baseline, and also now the advance this year is that there's a database that Consuelo is doing that actually when you input the data every month you can see, and it adds it to the graph, so you can actually see if there's anomalous times. What happened in the first year was that you often couldn't see the data until a few weeks later. But it's something that we're going that way. And Felipe mentioned this meeting with the Mapuche people. There they actually sat down with the Seremi, which is the Seremi de Salud.
Sí, no, Seremi de Medio Ambiente.
They're kind of like well, it's not the Environment Agency, it's like the Environmental Detective Forensic Agency. So yes, early days.
Sí, una pregunta muy corta. ¿Qué motiva a un voluntario a permanecer tanto tiempo haciéndole voluntario? ¿Cuál es la motivación interna?
Primero, por ejemplo, creo que la naturaleza en sí, poder como cuidar el medio ambiente, creo que ese es como el primer motivo por el cual uno tiene que llegar a nuestra medición cada mes, ya que como insiste voluntario, cualquier persona puede ir. Entonces van del abuelo, el tío, el primo, el hermano, chico que no es de ciencia y de otra área. Y también poder conocer el río, también conocer que Santiago no solamente está la capital, el centro, y que también tiene lugares de naturaleza que pueden ser llamativos y atractivos para poder conocer en el fondo como el sector.
So it's asking about the motivations to keep the volunteers going. Well, Felipe mostly mentioned like seeing the beauty of the river and taking your family there and just going to the river, which often in Chile is not that accessible. So it's allowing them there. But I'd also add that the community that it is built is really important because people are kind of coming together and lots more people were coming from Santiago than we expected. Lots of people, we thought it would mostly be local people, but lots of people come from Santiago because they didn't know where their water came from. So that's what attracted them.
Any other questions?
Te quiero felicitar y quiero decir que esto contribuye mucho con lo que hace la DGA, porque la información del Servicio Público de Agua en Chile no es completa. Entonces es muy importante que la gente se comprometa y estén haciendo estos aportes.
Igual ahí que me encanta hablar al respecto, porque la DGA, por ejemplo, es un organismo único que tiene más de muchos ríos como a cargo. Entonces por eso yo insisto que esta iniciativa sería como el primer paso para los ríos que ellos no pueden medir diariamente o mensualmente para dar una alerta finalmente. Como ya, si encontramos algo distinto, llamemos a la DGA, llamemos a Seremi, vayan a medir y luego viene la segunda parte de la parte legal para que ellos vean qué sucede como en el cuerpo de agua. Realmente creo que así se podrían enlazar y poder como trabajar en conjunto y abarcar más lugares donde se pueden medir hoy en día, ya que no se miden todos los lugares. Y es por semestre finalmente.
Can we just touch on something?
Yeah, so you're saying that well done on the initiative and that the fact that it complements well the Dirección General de Agua, that's the kind of national water body.
Yep.
Because we're kind of adding more data to it. And another thing that one of the students mentioned there was that there were a lot more points from Voluntarios por el Agua than there were from the Dirección General de Agua, especially in the pandemic. There were 2 measurements in that year. So we had 12, for example. So even though it's citizen science, there were more measurements than the national measurements at the time.
Well, last question?
No, I just wanted to add that the public service in Chile, the data is not complete. So this is a huge contribution because if you go into the web service, it's not there. So this is very good.
And it doesn't say the time. Doesn't say the time that they measure.
It is there, but it's not false.
Just one last question before we go to our next, if I may. There were some photos, I think there were some indigenous communities involved. And I'm wondering if the interaction, especially people coming from Santiago, awareness in terms of water beyond just drinking and in terms of its spiritual significance for indigenous communities, has that been part of this experience?
Yes. Explica algo sobre Mari. So she's a volunteer that's been there since the beginning. This woman who's a Mapuche activist, and she started this
En el fondo, primero comentar que en Chile que hay muchas agrupaciones mapuche, también de pueblo originario, que se asientan en diferentes lugares de regiones respectivas. En particular, este punto esta agrupación o esta agrupación ancestral mapuche se asienta en el río Maipo, pero en la parte de Puente Alto. Entonces ellos querían formar un nuevo punto de monitoreo en lo cual nosotros lo apoyamos como asociación y el pasado 5 de diciembre, el primer domingo del mes de diciembre, fui con diferentes amigos científicos también a poder medir con ellos el río Maipo y la calidad de agua respectiva. También ellos nos enseñaron un poco de sus rituales, cómo proceder antes de poder medir, ya que ellos nos hablaban un poco que hay que pedir permiso a la naturaleza, hay que pedir, por ejemplo, permiso al suelo, al aire, al agua en sí, y también pedir para más fortaleza y medicina respectiva como durante el año en su enseñanza mapuche ancestral. Entonces fue algo súper bonito porque hicimos una ceremonia respectiva de inauguración de medición y luego medimos en el río respectivo y también los chicos cuando hicimos una medición hicieron como una ceremonia con instrumentos propios tales de mapuche. Y fue algo súper bueno, muy bonito.
There was a ceremony with lots of rituals and they kind of they gave thanks to the earth and to the water. And they included, so they had their own instruments, they had their own instruments, and there were scientific instruments. So it was a nice match between indigenous and science.
Awesome.
And so this woman there with all the photos, she's a real leader in that.
Ahora también comentarles que los procesos que ellos explican, por ejemplo, científicos de purificación de agua, nosotros explicamos con la parte científico-química, pero ellos lo explican de su forma, cómo lo ven en la forma original. Entonces fue rico y también como llevadero poder unir estos pensamientos de la parte científica o medición y también la parte ancestral, ya que se complementan mucho y bastante lo que ellos hablan, por ejemplo, de, no sé, turbidez de río, un ejemplo, hablan mucho de la estación del año de invierno, nosotros hablamos mucho con el tema del sedimento. Entonces vamos relacionando muchos como conceptos entre la comunidad y lo que es la ciencia. Algo súper...
Yeah, the mix of languages and visions between the ancestral and scientific has been really good.
Wonderful. Thank you very much. Thank you very much. Our next speaker is Consuelo Martinez Fontaine.
Yes.
And this is with Communities and Coastal Watersheds.
Yes.
Welcome.
Thank you. I'm Consuelo. I work here in the University of Del Desarrollo in a center that is, yes, like an alliance with this, you know?
Yes.
El Centro de Investigación en Tecnología para la Sociedad. And I will be presenting a work that I've been doing this year. It's a work in progress. So maybe you can give me some ideas. It's a groundwater variability observatory, and we have been working on it with rural sanitation services in those watersheds, which are relatively small watersheds in the coastal areas of Chile. And I'm doing it with and with some collaborators from France, in Rio France and in Lyon, France. Okay. Yes. Right there. It's not there. No. It works. No, like that. Just a little bit of context, which you probably already know, but we are in a water crisis in Chile, which is multi-dimensional. It's related to climate change and less precipitation, but also there's bad water administration, migrating populations within Chile, and intensive use of water by some industries. And the place that I'm working on is here, and you can see here it's very precipitation deprived in the last 10 years. And the crisis is, it doesn't, how do you say, impact different communities the same way. Some communities are very vulnerable. In particular, one of the communities that I'm interested in part because my mom is part of one of these communities, are rural sanitation services. In Chile, in general, in rural areas, there are not sanitation companies that go there and give you water because there's no profit. So there people organize. For instance, we live in a rural community and we don't have access to water because we don't have enough money for it. So we organize, and then the state gives us some tools. They build the infrastructure to get water and distribute it. It teaches how to do it, but then it's us who have to administer this. And generally, it's people that don't have many tools because they haven't been trained. And in the last year, because of the drought, they are having a lot of problems. For instance, before they took water out of surface water, but now all of the surface water is dried out, so they have to build wells. But that takes a lot of time, like finding where to get the water from, then building it, connected to the distribution network. It can take more than 5 years. And in the meantime, people are very stressed because they don't have water all the time. Maybe half of the week, one day on, one day off. It's very stressful. And one thing that they're missing, or I'm interested in use efficiency in the use of information. So I thought with my collaborators who do visualization, information visualization research, what we could do to help this problem. And so we thought, okay, people don't know where groundwater is, and I know also because I'm a geologist that the information of groundwater and water in general is kind of opaque and incomplete. So we thought we can do an information system for them of hydrological information. And we did like with a co-creation approach, so we did it with them. We chose a place to work in. This is the place. This is the coastal watershed. This is Santiago in this tiny map. It's kind of north and west of Santiago. It's relatively small. And here the dots and the yellow lines are rural sanitation centers. And the center had been already working in this area. So I decided to do there the work because it's important to get to know the people and it's kind of slow. So we went there. And the first step was getting to know the people. And so we went to meet them. We interviewed them to get to know how they work, what are the problems, if they use information of water, if they produce it. We did some participatory mapping to understand how they situate themselves in the territory, etc. And well, the results from that are not surprising. Like they have water scarcity problem, and mainly because there's no precipitation in the last years, very few. And what they do when they have those problems, they contact the Water Works Agency. So we talk with the Water Works Agency to understand how they work, and they work very like in the emergency. For instance, one of the places they run out of water, they contact the Water Works Agency, and so the Water Works Agency they have to find a place to get water from, then build the thing, and that can be like 7 years. Right? And they don't do like it's very punctual in space and time. The Water Works Agency doesn't have like a database or understand how the watershed works. They don't project the works to the future, and so maybe when it's done, it's already dry, the well. So we said, okay, what we can do, and it's interesting for us, it's a groundwater observatory. And for that, it's very important to have data. But is there any data? Well, as she was saying, in the water agency, in this area, there are no official groundwater monitoring wells because it's a relatively small. So there's no official data there. There's only like bits of data that you can get from different areas. And the Rural Sanitation Service, they produce a lot of data, but it's not published and publicly accessible, not even for the water agency. So my question, or what we can do is, can we integrate all these data sources for the rural sanitation services and the water work agency to make decisions and prepare for the future? And maybe, for instance, say, this well is going to be dry in 3 years, so we'll start now. No, when it's done. And where are we now? We're interviewing some experts from the agencies that work with the rural sanitation services, academia, consulting, agencies, consultants, to understand what information is good, how to filter the information, how to evaluate the quality, etc. And they told us they have the same problems. The data is sparse, difficult to access, etc. And one very concerning thing is that the water work agency doesn't have a system to organize data. It depends on the people in charge at that time. So maybe if he goes, then that information is lost. And they told us a lot of information on water levels is lost on time. So what we're doing this now, and something I want to show you, because I think it's interesting, is that in the meantime, I've been gathering all the data that I can. This is this watershed, these are the sanitation services that we visited, and this is the information that I've been able to gather from phreatic and static levels, which is an indicative of the equilibrium state of the aquifers. And it's not that good data. This last part is the Water Works Agency gave it to me. It's data from the wells from these rural sanitation services. But we know from talking to them that they have more better data from this time on. Then in this other watershed, these rural sanitation services have information from here on, which is more better. And in this other one, very little data, but these sanitation services have way more data that is very valuable, and it could be made available for them and for other people. So I think the value or the contribution that we can make is to value their information, that they and the water work agencies know how important it is, and it's available not only for them, but for all people. Because also these kind of places are spread all over Chile, so we could have better data to prepare ourselves for the future. That's all. And now I'm working on that. Then I've talked with the rural sanitation services, so if they want, what do they think about the idea? If they want to give us the data, they said okay, and we have to go and visit them to understand how we're going to.
Interesting and challenging work. Questions, please. Y esto, bueno, trabajo también en los servicios sanitarios rurales acá en la región del Biobío. Entonces, tenemos problemas, o sea, los problemas que tú te indicas son similares a los de otras regiones. Yo creo que es bien importante a lo mejor colocar estos temas a propósito de que hoy día actualmente en el Ministerio de Obras Públicas se está discutiendo la ley de servicios sanitarios rurales porque hubo una oposición de los servicios sanitarios rurales a esa ley. Entonces, por lo tanto, están analizando hacer una gradualidad mayor, o sea, una mayor gradualidad. Entonces, estos temas que usted tiene es súper importante, a lo mejor hacérselo llegar a PR Chile, digamos, que es la institución que agrupa a la comunidad, y eso creo que es importante. Eso es como un dato, digamos, para que ustedes ahí. Y lo otro es preguntarte cómo ven la gente de los servicios sanitarios rurales esta forma de monitorear, cómo lo reciben, cómo lo ven para adelante, el involucramiento, cómo es.
Sí, in English?
Can you help us understand the question?
Because
Because it was a long question.
The comment was, ¿cómo se llama la ley?
La ley de servicios sanitarios rurales, que el reglamento de la ley de servicios sanitarios rurales está hoy día en actualización con los servicios a nivel nacional.
Well, there's a new law that's just been put in place for, how would you say this?
Rural sanitation.
Well, so yeah, and so he's saying he's from the Bio region, and it's interesting that they're going through the same issues, and they're wondering how they kind of complement the law with this, gathering this new data.
And maybe we can let the people, like the rural sanitation services from all Chile, they have like a, I don't know, like a group, to tell them this because they are discussing the new law, so they can tell this. And then
¿Cómo persiguen los miembros de los comités que están haciendo y cómo lo ven particular?
Sí. How do the people from these committees view the things that we are doing? And how do they see it for the future, like the project? They are very open in general. It depends a lot in the sanitation sector. But we have a bias because the ones that we're working with, they are generally more open because they accept that they want to work on this, and they are very willing to give their information, but some of them don't really understand what it means, the information. Some others, yes, they are more prepared or they've been working more time in the sanitation sector. So one of the challenges is how to communicate this to them so they can see the same value I see in really, they are very well, I love it, but I don't know in time if they will continue to be like that. And for that, I have my allies in information visualization, who I hope they will help us communicate this more intuitively, less scientifically.
Thank you. Good question. Any other questions? Please.
I want to ask about how the data is or will be maintained or collected, because as we can see here, the data isn't complete or has gaps.
Okay.
So how are you going to solve this moving forward?
In the new sanitation law, in time, the biggest is rural sanitation system, then the medium size, and then the smaller size, they are all forced to have a telemetry system that is all the time measuring the levels. So that already exists. It has to be translated to like, but the information is, most of them, they already have the telemetry. And they are producing the data all the time. It's just not being shared with anyone.
Any further questions?
The data that you're gathering, is it more about water levels as opposed to water quality?
Water levels, yes, because when we went to talk to them, we thought maybe they were concerned about water quality because there's an industry place that is very polluted and very known for that. So we thought maybe they were worried about that when you don't have water, you are more concerned about having water and then maybe the quality of it. So now for the moment, quantity of water and then first quality.
Yeah, first quantity and quality.
Yes.
Very, very important work. Okay, our next speaker is Camila. Camila Ibarra will describe adaptation strategies to address water scarcity while conserving cultural heritage of an indigenous community in the Tarapa region of northern Chile.
¿Me va a ayudar con la traducción? I'm sorry, no, speak English. Yeah. Okay.
Es todo. Ya, hoy día les voy a presentar las estrategias de adaptación a la escasez hídrica para la conservación de usos tradicionales con casos de estudio de las comunidades indígenas de la región de Tarapacá, norte de Chile.
El botón para bajar, la flechita para bajar en el teclado.
Hay un nombre.
Ay, de acá.
Ahora, digamos,
Acabado de mencionar. Ya. Ya. Bueno, esta investigación se enmarca en un proyecto mucho más grande que se llama Cuscaya. Cuscaya significa juntos, trabajo colaborativo, y es un proyecto de infraestructura adaptativa para promover la residencia comunitaria en el norte de Chile, en donde están involucradas varias instituciones, dentro de esta el Centro SMI de Chile, la Universidad de Queensland, el Patrimonio, EDP y nosotros como Centro de Investigación de la Universidad del Desarrollo. Este proyecto tiene tres ejes, energía, residuos y agua. Obviamente yo lo voy a ver ahora. ¿Ya? Ya, entonces, como contexto, las comunidades indígenas del norte de Chile han sabido adaptarse a las condiciones áridas del desierto de Atacama, viviendo en los valles precordilleranos. Y su cosmovisión, sus formas culturales y tradicionales le han permitido permanecer en este lugar. Pero hoy en día el mundo desarrollado y el cambio climático hacen que cada vez los recursos sean más escasos. Para el eje de agua se trabajó principalmente con dos comunidades. Estas tenían varias diferencias significativas. Una de ellas era la comunidad de Quivisca, en donde las personas no viven en esa localidad, sino que van los fines de semana y se usa como parcelas de agricultura para generar su cultivo de subsistencia. Ellos van principalmente los fines de semana y la población fluctúa de 20 a 60 personas. La comunidad de Macaya es diferente porque aquí las personas sí viven ahí. Entonces, el agua con la que cuentan es usada tanto para sus usos tradicionales de agricultura y prácticas agrícolas, como para el abastecimiento de las personas. Aquí viven de 50 a 60 personas. Quiero destacar de que las fechas de festividades pueden llegar a tener como máximo de 250 personas. Ya, metodologías. Contamos con 4 etapas. La primera de estas fue exploración y caracterización, en donde se identificaron las necesidades del monitoreo, se definió en conjunto con la comunidad las necesidades y objetivos del proyecto, se realizó un mapeo preliminar y se desarrolló como una propuesta de monitoreo, todo esto en conjunto con la comunidad, principalmente usando mapeo participativo y entrevistas socioeconómicas. Posteriormente, en la etapa 2 se hizo un codiseño participativo en donde se caracterizaba la dinámica hídrica, se propuso el sistema de sensores y se explicó cómo estos funcionaban. Se implementó y validó los sistemas inteligentes de monitoreo de sistemas hídricos y se hizo un codiseño de la visualización. En la tercera etapa se hizo el monitoreo y plataforma de creación, en donde se trabajó en robustecer la transmisión de los datos, el procesamiento y la entrega de estos. Se exploró la validación de los sistemas y se trabajó en la interpretación de la información, tanto por nuestro grupo de trabajo como por la comunidad. En la última etapa es la de prospección. Entonces se desarrolló en conjunto, en una co-creación, modelos de demanda y oferta hídrica. Se está pensando en generar, o se tiene contemplado generar, un modelo hidrogeológico de estudio para generar factibilidades de dónde podría estar el agua. Se deben validar los modelos, generar instrumentos de proyección a diferentes escenarios futuros y promover la gobernanza. En esta etapa nos encontramos ahora. Ya. Entonces, como resultados, o así como la primera etapa de caracterización del concepto hídrico, se rescataron las importancias culturales de las actividades, en donde se puede decir de que la agricultura de subsistencia se desarrolla mediante canales de riego, y los sistemas de regadío se basan en un sistema de turnos que pasa de generación en generación. Entonces, este sistema se llama cochadas y ellos se van repartiendo. La cochada es una medida de agua en el tiempo que les corresponde a las personas y que van transmitiéndose por herencia. Bien, otros usos importantes, y es una de las prácticas importantes para mantener el agua en situaciones de escasez, es que ellos se bañan y lavan su ropa en las termas o fuentes de aguas que tengan. No se bañan en su casa. Y no cuentan con agua potable. Bien. En base a estos dos comunidades con las que se está trabajando y la identificación de sus necesidades, se desarrollaron principalmente dos propuestas, una para cada uno de forma independiente en base al trabajo que se hizo colaborativamente con cada una de ellas. Para Macaya se estableció el plan de manejo y prospección del recurso hídrico enfocado en aumentar la resiliencia para cambios ambientales futuros y socioculturales. Este consideraba principalmente el monitoreo de los niveles de los estanques. Y para Iquiuca se realizó un plan tecnológico de recurso hídrico enfocado principalmente en los usos agrícolas. Entonces aquí se monitoreó tanto el nivel de agua como la humedad del suelo de los predios agrícolas. Bien. Aquí están los diferentes tipos de sensores. Este es el sensor de humedad del suelo. Y aquí vemos el sensor de nivel de agua. Ya. ¿En qué consiste cada uno de los nodos que monitorea? Ya, el nodo cuenta con un panel de energía que suministra energía de forma independiente a cada una de estas estaciones. Cuenta con un micro SD que almacena la data recolectada. Obviamente cada uno tiene un sensor que mide lo que le corresponde medir. Y lo más interesante es que estos sensores que están dispuestos a una distancia, por ejemplo, en Macaya, los sensores están dispuestos en una distancia de menos de 1 kilómetro, entonces se pueden conectar vía radio. Después, toda esa información llega a un gateway que después nos retransmite en base a paquetes de datos la información a un almacenador de datos. Ya. ¿Qué es esto? El gateway es el que redirige la información y nosotros la almacenamos en una nube. Bien. Posteriormente, se trabajó con la comunidad para la co-creación de cómo ellos iban a visualizar la información. Aquí vemos cómo ellos dibujaron y escogieron las formas en que ellos iban a visualizar desde la página web que les iba a abastecer la información que nosotros estamos recopilando. Aquí tenemos el primer diseño de la página, en donde se ve el estanque de almacenamiento con el nivel máximo, el volumen de agua disponible en el momento en donde fue actualizada la página, los puntos de monitoreo en el mapa. Aquí las leyendas son sensores de nivel de agua y estos son sensores de humedad del suelo. Y aquí también se muestra la infografía para los sistemas de humedad del suelo. Esta es la nueva página que está basada en ArcGIS Online, en donde tenemos un history map. Ahora contamos con un mapa como más robusto, más bonito. Y aquí también se pueden mostrar todas las variables de una forma más amigable. Vamos evolucionando. Ahora nuestro nuevo desafío es que en esta misma página se hagan preguntas como ¿con cuánta población contamos? ¿Qué queremos plantar? Y la página pueda decir que si el agua que tenemos disponible nos alcanza para eso, y si no nos alcanza, ¿qué alternativas podemos considerar para tener esa agua? ¿De qué forma? Ya. Bueno, ¿qué se hizo con toda la data? Porque no solamente como recopilar datos y entregárselos. La idea también es generar, queríamos calcular la oferta y demanda. Y para ello generamos un modelo conceptual que después se volvió un modelo dinámico para el cálculo de estas variables. Aquí. Ese era el de Macaya y este es el de Yucca. Se hizo uno para cada uno. Ya. Y ya. Nuestro primer cálculo se hizo considerando una base de datos de 207 días. Y los supuestos del modelo son los siguientes. Que la demanda total de la comunidad está compuesta por la demanda y la demanda poblacional. Que la demanda poblacional considera un mínimo de 30 personas que puede fluctuar hasta 250. Que el mínimo de demanda poblacional está regido por un intervalo que va desde 50 a 100, que corresponde al mínimo recomendado por la OMS, que el consumo es una variable que determina cuántos litros consumen las personas, y que un evento de déficit es la ocurrencia de 3 días consecutivos bajo el mínimo recomendado. Y aquí tenemos los resultados del modelo. Aquí vemos la gráfica, que es el consumo de personas por litro y el tiempo. Y la línea rosa es el límite mínimo requerido recomendado por la OMS. Entonces, podemos decir que el mínimo, o sea, el promedio de cada persona fue de 55 litros, pero que el 61% de los días monitoreados, las personas contaron con menos del mínimo, y el 47% corresponde a un nivel por debajo de los 10 litros. Que frecuentemente la demanda no es satisfecha y que en promedio los eventos de déficit duran más de 9 días. Aquí en este gráfico podemos observar, esta es la demanda y el consumo. Y vemos cómo la demanda supera con creces el consumo que pudieron alcanzar las personas. Y entonces, como conclusiones, el agua no fue continua y generalmente es interrumpida o pasa por varios periodos, eventos de escasez. Esto afecta el desarrollo cultural, tradicional y las actividades cotidianas, que también afectan cómo ellos se relacionan entre sí, promoviendo que las personas más jóvenes migren y se vayan abandonando su cultura. La información recopilada por el monitoreo es una prueba innegable de su realidad y que es un instrumento con potencial para generar soluciones estratégicas, y que la participación y el codiseño y trabajo interdisciplinario fue fundamental para el desarrollo de este proyecto. ¿Recién?
Te agradezco, o sea, felicito al equipo por ese trabajo. Logró súper buena labor. Y pregunta, bueno, y también refleja la disparidad que hay entre el mundo urbano y el mundo rural. O sea, tenemos una brecha tremenda, digamos, y un dolor de la gente por 10 litros por día es una cosa impresionante para mí. Quería preguntarte, esas tecnologías de qué nivel de costo son para un lugar determinado, para esa área, para tener una idea de cómo se pueden extrapolar a otras situaciones, y nuevamente cómo el sector público y el sector privado, los stakeholders, digamos, del lugar, toman esa información para aprender un poco del proyecto.
Bueno,
Sí.
So he's congratulating them for the effort and the problem that there is a big difference between urban and rural water supplies in Chile, and it's just completely unfair that some people are living with less than 10 liters of water a day, and he's asking about the instruments and how that could be of use to further policies.
En verdad los costos no los tengo tan claros, pero creo que la transmisión de datos es lo más caro y como tenerlo en una nube y generarlo de la página era lo más caro, como que en insumos para como establecer el nodo son como 500.000 pesos chilenos. Sí, eso cuenta como en el panel solar y todos los sensores, el dispositivo, pero para cada uno, porque en cada una de las comunidades se contaba con más de 7 aproximadamente. Y sobre la gobernanza, ha sido un desafío porque estamos muy lejos. Mantener la comunicación tanto con la comunidad es complicado, pero nos arreglamos y hemos generado buenas relaciones con ellos. Ellos confían en nosotros y por otro lado está como con los otros stakeholders, los otros actores que podrían tener como mayor incidencia. Ha sido súper difícil ponerse en contacto con ellos y son ellos los que tienen el contacto con las autoridades y hace como un mes nos solicitaron un informe que iba a ser presentado a la delegación presidencial. Y nosotros como que queremos que este informe como que sea la evidencia final para que les den una solución.
She was saying that the census themselves are about $15 for each set, but there are 7 of them in each community. But the most expensive thing is sending the data to the cloud. That's in the most expensive. And in terms of the governance with the actual people, the relationship's been really good and really encouraging. It's been that kind of middle ground between local people and the authorities, and they're asking for reports, but that's where the communication breaks down a
bit. Bueno, igual me sumo a las felicitaciones. Cada vez que yo veo esto, sigo convencida de que es el trabajo que tenemos que estar haciendo, poniendo a disposición el conocimiento científico, el conocimiento experto, en beneficio de comunidades, como el caso de esto, comunidades indígenas que tienen su propio conocimiento, tienen sus propios saberes ancestrales, como tú decías, Felipe. La conjunción de esas cosas son las que generan los cambios en los territorios. Y aquí hay un ejemplo súper interesante. Recuerdo una conversación que tuvimos con la comunidad de Macaya, donde ellos nos contaban que la escasez de agua que tienen implica que el gobierno local, en este caso la municipalidad, les provea de agua a través de camión aljibe, ¿sí? Pero la decisión de cuánta agua, cuántos camiones aljibe y en qué periodicidad depende de la municipalidad, no de la necesidad que tiene la comunidad. Entonces, ellos visualizaban en esta herramienta un potencial para dar la señal al municipio de decir, a partir de mañana nos quedamos sin agua, así que el camión aljibe tiene que operar, ¿no? Entonces, es como otro tipo de relación también con las autoridades locales. No es solo la demanda, queremos agua, necesitamos 3 camiones. Es como, mira, lo que está ocurriendo, aquí están los datos, la municipalidad podría eventualmente acceder a esta información y tomar decisiones de manera informada. Y no en un ciclo de visitas de un camión aljibe que no responde al sentido de la demanda de agua, especialmente por consumo, que es el problema que tienen Macaya. Sí, sí.
Yeah, so it's saying that before it was a bit random when they sent the trucks with the water, there was no kind of real reason. It wasn't like designed for what the people actually knew they needed.
Yep.
But now this is a mechanism that they could actually be a bit more quantitative, and the locals could actually be looking themselves at what the data says, and then they could make that direct link so they know which season they need more water. Calculated a bit better.
A super challenging project, and looks like you're doing amazing work. Thank you very much. That's it for our last presentation. And Melissa will offer some insight into her engagement with the Likan Antai community of Caspana, highlighting 2 interrelated processes, cultural and water resource mapping, and empowering indigenous communities. Welcome.
Thank you. Thank you, Margaret, for inviting me. I'm going to contextualize a bit because I'm not an engineer. I think most of you are. I'm an architect and I'm a landscape architect too, and I work with cultural landscapes. So my focus is more from ethnographic practices. So that's what I'm going to tell you today. It's about a cultural mapping process that is part of my PhD and another process that was running parallel to my research, which was a water resource registration in Caspana. As you saw the images, the previous presentations, I'm upper north, not south, sorry, so I'm at the bottom. So here you can see indigenous areas, in blue you can see the most of the populations and in black indigenous communities, and I work in the yellow one in Caspana and nearby Chichu. So that's another presentation. So this is a close-up you were seeing today, earlier today in Alama. This is the mining company nearby this way, and Caspana is here. This can be considered as one of the highlights. So it changes the scenery a bit. And I'm going to skip this part, not going to focus into the distribute. This is my method that is grounded in cultural mapping practices. And when I visited Caspana in 2018, they had a map. They had a map that was built by archaeologists, and they needed to update the map. But I knew that it is hard to work with people, let's say just people with math, if they don't have the language. This is a scientific language, and not necessarily everyone gets it. And sometimes it is even difficult for us to locate ourselves because it's in the middle of, you don't have many references. So this method invites you to build models, 3D models like maquettes. And originally, this is a method designed by the UN, so it's much more sophisticated with plaster, and you end up making like amazing models with a team of 15 people. And I didn't have that. This was my research. It was just me. So what I did was to travel there with 2 cardboards, and I printed a satellite image so that it was easier for us to see. You can see infinite amounts of ravines and creeks and hills. So it was easy for us to see changes in colors and then to see that as a model as well. So that facilitated the process. I mean, if I explain to you how I contacted them, and I could be hours, so I'll just move to the process itself. And this first visit, they wanted to create a map of different resources in their territory, so they could use it as an argument for claiming their land. So it's part of an ongoing process, a legal process with the state. So if they can reinforce their demand with this kind of activity, saying that we are here, we know what we have in our territory, which is massive as well. So the first, this is part of the mapping process. It was around 5 days with different community members. It was really hard to locate the community, the boundaries, every aspect that for them was valuable, but we did it. And once I finished this, they kept it, the maquette, and then they use it a lot until it got ruined because it was raining, and it rained on the shelter that they were using, and they asked me for another one. So, sorry, this is the part of the first one. You can see all the resources, and we were saying like all the water that we have. This is navigators. This is the most like touristic part of the north of this region. And these are the cropping, the agricultural sites. So, and part of cultural mapping asks you to work with the legend with them. So they decide what they want to locate, what and why. And the wadas are key places in this presentation, of course, for them, because they are the source of water, not just the creek, not only the ravine, not only the river, but where the water emerges from the earth. So, and this is something I was saying because they asked me. So in blue, you can see all those water sources, But then they started the parallel process because they realized how important it was to get the exact point, the exact GPS point. And of course, this maquette was not giving them exact, precise location. So this is the finalized model. And part of this method involves mapping this from photo. So you can have all these points on a map. So I handed them this map on the first version, so you can see all the places, and of course there's archaeological sites, places where they perform rituals. So all that is here. This is what I call the maps of relationality. That is part of a literature review that I skipped today. This is the return of the map. I know that they've been using it, but they use more the maquettes that got raised. So this is what we did to maybe kind of decide where we were working, because also the extent of the model is very important, and it's part of the mapping process that is decided at the first meeting. And this second time, they had an ongoing project of place names in Hunza, because it's their languages and they are using it. I mean, nobody speaks Hunza anymore. There is one person who is kind of trying to learn back the language, but they wanted to do their own kind of collective memory process of, and having this map and walking around it and spending hours and hours help everyone to kind of locate those memories and why those places have that name, and not only Kumsa names, but also Spanish. It's a mix. And it was also a very important process, because it made me realize that there is a connection between these water sources, the ravines and the hills. So it's all part of the same demonic process of naming places and the change. So what happened next is that it was the pandemic. So I was in Edinburgh here, but we saw a fund that we could apply to Banali for collecting medicinal plants. And what is interesting, and how I connect this with our mapping project, well, as you can see, we were working on WhatsApp because I was too far away, but I helped them to create this book and inventory of medicinal plants. But they were, again, mapping with coordinates. They were also mapping what was around the plants, because in many locations, especially in the highlands, you only find the specific plants that were actually used to treat COVID around these water sources. So once we finished this, I was in parallel digitizing the photo of the second maquette. They sent me the GPS location of all those wells. And what happened next is that they did this legal register, because for those who are not here, water is private in Chile. So it's kind of who sees it first gets it. And all this water reads, I don't know how to call it, but where you get the first spurt of water from the highlands. So they registered those and they got it for them. So that kind of reinforces the right to land and water. And I was not part of this process. I kind of witnessed it from the side, and as we were doing this project, I saw it. But I find it very exciting, to see how, from working with models, maquettes, recording places, visiting and then themselves doing the work of getting the GPS data and getting the water for themselves. So yeah, that's what I was going to share today. I don't know how am I on time or not, but
We, you have a couple more minutes, you wanna just wrap up before a couple questions?
I mean, yeah, well, I have this, it kind of shows what we did on the first modeling process. The first time we recorded the waras, that's the name. On the second one, we were recording place names, but again, of those waras and the rivers and hills, that is somehow the same. And in the medicinal plant collection, we were registering plants, but the plants are associated with other references, so it's all part of the same language of relationality. And it was complemented with this legal registration. I see it as a part of an ongoing process, which I'm very proud I've been able to witness. Done.
An exemplary piece of action research in the sense that there's an immediate contribution to the community by registering water sources in the name of community members.
Yeah, and I think that the most important, or what I'm putting as a contribution in conclusion, is that they value the model and they own the model. And I use authorship here, but I get lost in this process because I'm part of some parts of it, but I'm not an author on anything that what they're doing. They are on their own, and just I'm witnessing. But the models I think is key, because the first maquette we were using it not for rituals, that is part of what the literature says, but part of teaching others about the territory, because not every member of an indigenous community knows every name of an immense territory, maybe a few, but they're using these maquettes to teach others. And it is actually kept now in the museum that they are. Also, Caspana is a very unique community. It's not that every community works the same. They're very traditional. They don't allow anyone to live in their community. It's a very close community. So I cannot say that everyone works the same way, but you know that this part is important. This is when I showed the first map. Here, all the lithium is here. And we are not too far away, but if you think this is all the kind of like, so ways of the close bond that they have with water here is massive. It's so everything that is happening around lithium is impacting every community a lot.
Absolutely.
With this map, what area can you just maybe point where you did your mapping exercise?
Here, this one. So all this, it's
kind of that downstream from the lithium deposits or upstream?
No,
is it? Yeah, I know it's north, but as far as the way the water flows.
No, the water, flows this way.
It flows east.
So the lower river does this, and it goes this way, but there's lots of rivers, at least 5 or even more, and Brahmin is thousands, so there is lots of water, but you can see it's part of the same system, but here is the source. So by protecting upstream, they're protecting the rest of
The rest downstream.
Can you just explain, when you say guaras, what is?
Yeah, that's what I'm not being able to translate. But where it begins.
Yeah, the spring.
The source. The source. The very point when you get the water from here.
This has been a fascinating session. Felipe, Consuela, Camila, and Melissa. especially for those of us who have come here to visit this wonderful place, to understand how uniquely embedded your communities are in terms of community involvement with issues of water. And all of this is in the context of an impending increasing wave in mining and putting these things under threat. It's been a pleasure to learn from all your great work, and I hope that it continues with greater force. Thank you so much for all these sessions. Encourage everybody, we have lunch. I encourage everybody to continue conversations outside and to learn as much as you can.
It's got too big. This is just one.
Okay. I'm a little worried. Yeah. That sounds much more exotic.
I concur right now. Pretty much. Good to advertise. Program is surrounding stuff is magic.
Yeah.
So just okay, it's still working on it.
Yeah. Deserves.
Should also note, Chris is from Trent University, the senior
Professor Emeritus.
Professor Emeritus, senior editor of environmental archives, environmental contaminant and toxicology.
Yeah.
So he knows what he's talking about.
No, that could be debatable.
Chris,
Anyway.
Chris, I'm a terrible timekeeper, so I'll at 2 minutes to the end of your talk, I'll stick with a paper that says 2 minutes.
Okay, well, thanks for rushing here after lunch. I'm going to be talking, with my shadow away from the thing. We're going to be talking about organic contaminants, which is a little bit of a switch from a lot of the presentations we've had about metals and other elements. So this comes from a project that I'm currently involved in, and it involves myself and my colleague Vivian Yargeau. She's at the Department of Chemical Engineering at McGill University. And I will put in a plug for the fact that this is being done through the auspices of my consulting firm. A huge consulting firm consists of me, Ambient Environmental Consulting. So we're working with a municipality as our client. I'm not supposed to tell you what that municipality is at the moment, so it will go unnamed, but it's near Toronto. So some of you might not know what contaminants of emerging concern or CECs are. They're typically organic compounds, although they don't have to be. But they're typically organic compounds. They're produced for a variety of uses in industry, but also as personal care products, pharmaceuticals, etc. And they can be released into the environment both from point sources and non-point sources. And why we call them contaminants of emerging concern is that they have not yet been regulated or banned under any international or national programs. So there are no, for instance, guidelines on what kinds of concentrations are allowed in the environment, in rivers and streams, etc., or in foods, etc., at this point, because there's just not enough toxicological information in order to drive those guidelines or bans. Now, having said that, there are some compounds which are regulated, and we'll talk a little bit about those. Some of which have been banned under international conventions, but other members of the same class of compounds are still in circulation, are still being used for various purposes. So, which ones should we be worried about? There's hundreds of possible compounds that have been detected in the environment, and now with non-targeted approaches for analysis, the pace is quickened. There's large numbers of compounds which are being discovered every day. And so the problem is then, if you're going to focus in on those which are particularly hazardous either to the environment or to human health, how do you do that? So we were involved in that process. The traditional way in which compounds have been evaluated is to determine whether they are persistent, bioaccumulative, or toxic, PBT. But in the case of some of these compounds, that's not a particularly useful way to decide whether a chemical should be regulated. So for instance, endocrine disrupting chemicals or compounds, EDCs, many of them are not particularly persistent. They don't hang around for a long period of time. Many of them do not bioaccumulate. And in terms of their toxicity, typically it's sublethal toxicity. They don't actually kill the organism, but over long-term exposures, they might have effects, for instance, on the endocrine system. So our client, they wanted to know which compounds we should be concerned about, which compounds they should be monitoring in both their wastewater and in their drinking water so that they can kind of get ahead of potential regulatory concerns. The Ontario Ministry of Environment is constantly coming up with new monitoring regulations, as well as our federal government in Canada. And so they wanted to get ahead of that. And also they field a certain number of questions from the public about potential contaminants in drinking water in particular. So they wanted to be able to answer those kinds of questions. So our approach, we only had 4 months to do this. So our approach was basically to hit the literature, particularly reports and guidance documents. So we looked at some watch lists for lists of chemicals which are priorities for the EU, for the US Environmental Protection Agency, as well as in Canada. So we combed through all of those and added them to our list of compounds we were interested in taking a look at. We were particularly happy a few months ago to receive a copy of a project that was run by the state of California and the USA, in which they had basically gone through the same process. It took them 3 years with an expert panel of some 10 or 12 individuals where they gathered all the toxicological and monitoring data they could get their hands on and came up with their list. And so that was particularly useful for us. We also took a look at peer-reviewed articles. We convened a panel of experts that we met with to discuss our findings and recommendations. And then finally, just our professional judgment from the research of both Vivian and I have done over the years on these types of contaminants. So that was our approach. And then comes the question, okay, what do you do with that information? We had 265, something like that. 265, I think it was, candidate compounds. We needed to whittle that down in terms of the compounds that we were going to recommend for monitoring. So what we did was we used a tool that was developed by the Water Research Foundation. We modified it somewhat. And basically this consists of just answering a bunch of questions. And I've put some of the questions here on, whether the compounds were on one of those watch lists that we were looking at, whether we know there's ecological risks or there aren't, et cetera, you could read it as well as I can. And then we would assign our level of confidence to our ability to answer those questions and to classify the compounds according to whether they might have some environmental or human health impacts. This took a bit of time because each compound had to go through this process. So I was beginning to think, well, maybe artificial intelligence applications might be something that we might look at in the future as a method to make this less difficult. So here's what we came up with from the list of 265. We came up with the top 100, still a fair number of compounds. And this is just basically a list of the classes of compounds that we came up with as being ones of interest that we would recommend for monitoring to the municipal client, both in drinking water as well as in wastewater. So they include perfluorinated alpha substances. We'll talk a little bit about those. A range of what I call down the drain chemicals. I'm going to talk about those as well. Tire wear compounds, which maybe you haven't really heard about too much, but you'll hear a bit about that in a few minutes. Various additives to plastics and other commercial compounds. And then finally some pesticides, insecticides, fungicides, and herbicides. So we decided not to include micro and nanoplastics. And the reason for that was that the municipality was already involved in a study with Bob Andrews at the U of T monitoring for both nano and microplastics. Decided not to include algal toxins. We figured, well, we'll just stick with synthetic compounds. And then finally, we decided not to do metals, just because. No, I'm kidding. We felt that in terms of the analytical labs that we had at our disposal, that we would cover that. So, per and polyfluorinated alpha substances, you probably know these from the headlines as forever chemicals, which is maybe a bit of a misnomer, but they do break down over time, but it takes a while for them to do that. But they are used in a whole range of products. Coatings for for food packaging so that grease and oil doesn't seep into the cardboard or the paper. Non-stick coatings on various kitchenware, tile and grout materials. So this wheel here shows you all the different applications for PFAS compounds. So every day we are using these types of compounds in various products that we have in our home and elsewhere. So two compounds in particular, which have long alkyl chains, they are PFOS and PFOA, they have actually been regulated now through the Stockholm Convention. So these are now banned in many countries who have signed on to the Stockholm Convention, including Canada. But there's a whole range of other compounds which are either perfluorinated, that means that they are saturated with fluorine on all alkyl groups, or polyfluorinated. There is fluorination, but it doesn't necessarily happen with all of the alkyl groups in the compounds. So you can see some of these compounds. Not only that, there are precursor compounds which are produced during the synthesis of these various products, and then there's degradation, transformation products as well, particularly when they are discharged into the atmosphere. So through photochemical transformations. So it's a mess. There are all sorts of compounds that could potentially be monitored. So the US EPA has come up with a list of, I believe it's 27 priority compounds, and those are the ones that we recommended that for monitoring. Down the drain chemicals, I've been working on these for quite a while. So that includes a range of pharmaceuticals as well as drugs of abuse. So for instance, opioid compounds, and it also, in particular, we were interested in neuroactive compounds. So antidepressants such as venlafaxine, which is the most widely prescribed antidepressant in North America, and its metabolites was one of them. Also, we're interested in a variety of antibiotics because of the potential for the development of antimicrobial resistance in the environment as a result of the discharge of those compounds. And then, as I said, there's a variety of other compounds which are drugs of abuse. So, for instance, codeine, which in most provinces in Canada requires a prescriptions, in Saskatchewan it does not, is a drug of abuse. It's used particularly among teenagers in addition with alcohol as a drug of abuse. So there are actually quite high concentrations of codeine in our rivers and streams and sometimes in drinking water in Canada. Personal care products. So examples are antibacterial compounds such as triclosan, which are added to antibacterial soaps as well as antibacterial toothpaste and other products. And then parabens, which are added as preservatives to a range of cosmetics. By the way, they have been banned in the EU, but are not banned in North America and South America. And then food and beverage compounds. We're not particularly worried about toxicity. I mean, we obviously consume a fair amount of caffeine and have some effects, I suppose, in large doses, but I mean, in general, these are fairly safe. However, if you find these in your drinking water, it's a pretty good indication that you've got wastewater contamination. So they could be fecal bacteria, for instance, that are also present. So we recommended monitoring those as well, just as an indicator of wastewater or sewage contamination. So these all, when we shower, when we defecate, etc., these all go into the sewage system and are washed into the wastewater treatment plants, and in many cases they are not removed within the wastewater treatment plants. They go into our waterways and potentially then could be taken up in as intake into drinking water treatment plants, or could have effects upon aquatic organisms downstream of those discharges. So we recommended a range of those. Also, you have natural and synthetic hormones, which are excreted by we humans, so that includes both estrogens and androgens, as well as synthetic hormones such as ethinyl estradiol, which is the active ingredient in the birth control pill. And these are very active compounds, so very low concentrations in wastewater, for instance, can have effects upon aquatic organisms. So then those are part of our recommendations as well. Okay. Let me just make sure. Okay, yeah, all right. So then there was a variety of additives that to plastics that we also recommended. So these include bisphenol A and its analogs, which are added to polycarbonate plastics, and also phthalates, which are added to PVC plastics to make them more flexible, but also some other surfactants, etc., and fire retardants, which are added to a variety of commercial products. Now, of course, we're mainly concerned with exposure in water in this particular case, but there's exposures to a whole range of other vectors as well through food, even contact. Small children who like to crawl around on carpets are exposed to these flame retardants, etc. So there's a variety of ways in which we can be exposed to those compounds. Now, maybe you haven't heard about tire wear compounds. This whole subject area started as a result of a particular syndrome called Coho salmon urban runoff mortality syndrome, which is a bit of a mouthful. And basically, this took place in the northwest area of the USA, in Washington State, and they were finding that at certain times, the coho salmon that were coming up to spawn in urban rivers and streams were dying off as much as 80%, 70 to 90% of the returning salmon were dying. And they would appear to be going into some sort of respiratory crisis and would actually expire relatively quickly within a matter of minutes once they went into these urban streams. So there was quite an intensive search to try to figure out, okay, well, why are these fish dying as they return to spawn? And eventually, well, first of all, they were able to determine that if they took storm water from these rivers and streams and exposed the coho salmon to that storm water, then you saw exactly the same mechanism of toxicity occurring in the salmon. So they knew it was stormwater. And then they started to do both targeted and non-targeted analysis to try to figure out what the compounds were that were responsible for it. Went down several rabbit holes looking at different types of compounds, but eventually, just in the last couple of years, came to the conclusion that it was an oxidation product of a agent which is added to tires in order to make them longer lived. It's basically an antioxidant called 6-PPD, but it wasn't the 6-PPD itself, it was an oxidation byproduct called 6-PPD quinone. There's the quinone substituent group on the 6-PPD, which was causing the toxicity. And this took quite an effort by colleagues at the University of Washington in order to come up with that conclusion. But there are several other compounds, such as diphenylguanidine, a compound called hexamethylmethylmelamine, HMMM, which are also possible as linking agents in tire, and they are also present in runoff from roads during storm events. So here's some data that was generated by my former master's student, Cassandra Johannesson, former student in the chemistry department at Trent University. And with the help of the Ontario Ministry of Environment, she was able to get some samples that were collected through a whole rain event from the start of the rain event through to 44 hours after the start of the rain event. And this particular figure I'm showing is from the Don River, which, as you can see, is just a few meters away from a very busy highway called the Don Valley Parkway, sometimes called the Don Valley parking lot because we have traffic problems there all of the time. So you can see that it's fairly easy to have runoff during rain events of these types of compounds into the Don River. So what was interesting was that if you compare that to the LC50, the lethal concentrations of the 6 ppdq to various fish species, salmon species, you can see that the levels that were maintained over several hours during and after the rain event all exceeded the concentrations for lethality. And so this was kind of an interesting study that showed that these tar compounds can certainly be lethal to aquatic organisms. And so that's why we recommended it to our client in order to monitor those in wastewater and drinking water as well. And then finally, I'll just quickly say that we also recommended a range of pesticides which are used for household use, agricultural use, and also for turf care in places like golf courses, which are also potentially could be making their way into drinking water sources. So in conclusion, there's a bunch of different compounds that we were able to recommend. We're in the process now of contracting various labs to do the analysis, including the Water Quality Center at Trent. But I always recommend what we call toxicovigilance, in that we're always behind in the regulation process, behind industry. In many cases, they're very nimble, like switch away from compounds which have been regulated or banned outright and switch to very similar analogs, which eventually we find out cause very similar responses. The example I give is bisphenol A. Many of you know bisphenol A. A lot of companies, put bisphenol A free, BPA free on their polycarbonate plastic containers. In many cases, the industry had just shifted to similar compounds, analogs called bisphenol S, bisphenol SF, etc. And the data seem to indicate that they're just as estrogenic as the bisphenol. So that takes place all the time. So with that, I'm a little over, but maybe there's a chance.
Hardly noticeable.
Maybe
Thanks very much.
there's a chance for some questions.
Yeah. At least 1 or 2 questions.
No, good.
Wait, I'll ask you that. Oh, okay.
Do you know if the municipality is actually monitoring for you now?
For at the moment,
For what you were proposing to us?
or you mean CEC specifically?
No, for like, because I guess from what you said, you recommended quite a wide range.
Yeah.
So are they going to start monitoring what we methods?
Well, that has to be determined. So we have to go through, we've gone through 2 rounds of collecting samples. We'll see what we find. And if I can tell you right now, we're finding lots of tire compounds, for instance, in both their wastewater and drinking water. So one would suggest that they'll continue to monitor for those. But we didn't find all that much in terms of pesticides. So we have to make that decision and come to.
They're not going to do any preventive
You mean trying to reduce the sources?
No, as in test for things that are not very accurate that might be concerned in the future.
Well, yeah, I mean, we could make some recommendations. The trouble in the analytical world is we depend upon analytical standards. And in many cases, if those aren't commercially available, then we're sort of lost. Now, we can do non-targeted analysis in which we can suggest what the compound is. It's not definitive without an analytical standard. But that's the problem, is if we're kind of looking for compounds that think might be a problem in the future, often that's an analytical problem for us.
so much, Chris.
Okay. I guess I have to.
Esa también.
Oh, here it is.
Very pleased to introduce Julian Ahern from the School of the Environment at Trent University. He's going to give a presentation about Ireland.
Oh, that one. What?
By monitoring of atmospheric microplastics, the good, bad, and the ugly. I expected to see a picture of Clint Eastwood on there. Anyway, so yes, take it away.
Thanks very much, Chris. So I should say that the talk will really just focus on this first part, biomonitoring of atmospheric microplastics. There's a couple of studies that I'll just summarize and pull together. I put this on thinking I'd be able to come up with something funny. A bit tired, and so I haven't been able to come up with something funny, so apologies. And there's a whole list of people here. Essentially, I'm just presenting their work. So this morning, I was up early before breakfast, and I headed down to Cerro San Cristobal. I took this photograph. As you can see, I think that's where we're staying, somewhere near that tower. And as I looked around, you could just see here in the distance something, and I have a great camera. It's my iPhone 6, and I zoomed in. And there were microplastics. I said, oh my goodness, there are microplastics in the atmosphere. And I shouldn't be that surprised because microplastics are everywhere. And as Chris mentioned, they're an emerging contaminant. I think there's some concern, it's emerging because there's still no known toxicological effects yet, or at least no indicators, but of course, leachates, etc. But it's well known that they are everywhere, even in the atmosphere here over Santiago. And so I'll just do a little bit of background. They're very hard to see. I was too lazy to change the coloring. When I talk about microplastics, I'm talking about plastic particles in the atmosphere that range between 1 micrometer to 5 millimeters, so it's 5 millimeters and down. This is the back row intro part. Typically, we talk about shape of microplastics, and that gives us an idea of source. So you can see here, we've got some fibers, we've got some beads, and typically we might talk about fragments or fibers. So fibers are something that are broken down from textiles, and they also may indicate whether it's secondary or primary, as in these could be beads, so they're manufactured to be small, but these could be broken down from clothing that we wear, so therefore they're secondary. One thing to note, it's a mixture, so it's not one class of chemicals, it's a mixture that could be polyester, polypropylene, polyethylene, etc. So it's a mix of contaminants. They're everywhere, and because they're everywhere, QA/QC is a tricky thing, so there's a lot of work on QA/QC. Basically, you don't want to be just monitoring yourself and measuring yourself. And this, if I was to do something funny and put a picture of Clint Eastwood in, I would probably put it in around here. The main unit that's used for reporting it is typically count. So you say something like found 2 microplastic particles, which is very unfair because you could have a tiny one here about 4.5 microns, or one here that's 4.5 millimeters, and they're both equal to each other. But of course, there's a lot more plastic in this one. Sometimes they're also reported as count concentration, as in the number of whatever environmental media you're looking at. So drinking water, 1 or 2 per litre. And so lastly, of course, once I saw these, I thought, well, how do we go measuring microplastics in the atmosphere? And we could use traditional techniques. This is just a high volume air sampler, so sucks air in, captures particles on a filter, you take the filter back to the lab and do whatever. This is a wet only sampler. When it rains, the lid comes off, it rains into the bucket, stops raining, the lid goes over and it closes it. So you've got your water sample in there. Or this is just a cheaper version of bulk sampler, doesn't need power. But there's a fancy one, it's got a little halo there to stop birds from pooping in it. Bird poop has microplastics as well. The issue, of course, is a little bit labor intensive. It costs money to put these everywhere, and you can't really put them everywhere. So biomonitoring may be another way. Biomonitoring refers to essentially using plants to look at pollution in the environment. And this here is a picture of moss. I'm not good with biological stuff, but I do know at least 2 species of moss. This one here is Hylocomium splendens. The other one I know is Sclerosium. And essentially they have no root system. They collect atmospheric particles as they fall. The tissue is sampled, brought back to the lab, analysed, and it's being widely used for trace elements, mercury, persistent organic pollutants, a number of contaminants like that, trace elements. And widely used since the middle 1960s, so we thought, well, maybe we could use them for microplastics. And we basically said, given that it's well established that moss has a high capacity to trap and accumulate atmospheric particles, can we use moss to assess the deposition of microplastics? And I've stuck in here ICP Vegetation. It's the International Cooperative Programme on Vegetation. It's a body under the UNECE Air Convention, and essentially they coordinate large-scale surveys every 5 years, where across Europe they collect moss and track changes in moss tissue content over time. The downside of moss is that, of course, it's not a direct measure of what's coming from the atmosphere, but it's a relative measure. You might say if it's high in my moss, it's high in that region versus another region. So we thought, well, why not look at microplastics? To do this, we decided we'd collect Hylocomium splendens because we can recognize it from 3 sites in Ireland following this IPC vegetation protocol. And so we made sure first, in this case, that all sites were remote. We wanted to look at sites that were distant, far away from potential sources. So essentially they were all distant from anthropogenic emission sources. We really want to see where microplastics travel in the atmosphere and if we could measure them in the moss. And all sites were in national parks or protected areas. So we have one here in Glendalough on the east coast of Ireland, but it's closest to the capital city, so closest to the highest population. Another one here in Loch Mamwe, which is more of a fishing lake. These are around those catchments, around those lakes. And Loch Tay National Park up here in Donegal on the northwest. Just for geographical references, myself and Grace come here, study or work here. We're here, and that's the study site. This is an example of one of the sites. This is Loch Fay. As you can see, it's a pristine region. Zoom in here. Essentially, the only public area here is a castle-ish on the lake, and visitors come down and visit here. We sampled over this side, and that's the type of sampling we did in most locations. This is a national park. It's far from urban centres, but it does get visitors. In terms of what we did in the field, at each of these lake catchment fee sites, we collected the moss, collected by hand, wearing nitrile gloves. They were coloured so we could spot where it came from them. And we used this ICP vegetation protocol. We took a 50 by 50 metre area and took moss from about 5 locations, composite, so we get a representative sample. And collect them away from tree cover, away from trails and roads or other anthropogenic areas of anthropogenic activity. So essentially, we just wanted to make sure whatever was falling from the atmosphere, not people who were walking by. I'll go through this really fast. This is the analytical process. I won't say too much about it, but I'll say enough. That's first us collecting the field. QA/QC is really big, so lots of blanks, lots of spikes. We put things in that we know should be there and try to recover them. In terms of getting the plastics from moss, we've been digesting the moss, putting it in hydrogen peroxide and a little bit of iron to digest it, thinking maybe that's too much work and we should wash it. Again, it gets filtered, assuming everything's being digested, it gets filtered. Particles are trapped in filter paper. This is the tedious part where we stick it under a microscope using bright field and also a blue light, so we might get some fluorescence to try and identify the particles. It's a visual identification technique, so it does limit us in terms of the size of particles. So essentially, we're more successful at particles greater than 50 microns. And everything we think is a microplastic, we take a picture of it, we touch it with a hot needle, it melts, then it was a microplastic. Some of them don't melt all the way, and because they don't, we can identify them under FTIR. So essentially, we take a spectrum and then compare it against the light. Ask others who are here. Brandon will tell you. In terms of results, Well, we found fibers. We didn't find many fragments. We've actually found fibers in all the moss samples. Some images here of the fibers. A total of about 300 fibers across the 3 sites. Average number of fibers of 23 per gram dry weight of moss. And the average length was less than a millimeter. And it did vary across the sites. The site, I think, that gets the most foot traffic had the largest fibers. The site that gets the least foot traffic had the lowest, smallest fibers, suggesting maybe that it's closer to a source here. So we said, oh, it seems to work. This moss thing may work. But when we come back here to this type of urban centre, of course, there's not a lot of moss in and around the city. There's maybe a little bit up here. There's really nothing around here. So we wondered if we could use moss transplants or moss bag technique to measure atmospheric microplastics. And essentially, you go to somewhere that has moss and you take the moss and put it somewhere where there isn't moss, leave it there for a while, it accumulates microplastics, hopefully. And then you do the same thing that we did in terms of analysis. So we made these moss bags. They're like little tea bags there. You can see someone holding it. Essentially, it's made of an aluminum mesh, which is sewn together with steel wire. And then inside this, we place 1 gram of moss. And we hang it out. I'll show it in a moment. But we make sure that the moss that we put in here comes from a background region that doesn't have a high concentration, we believe, of microplastics. And this is the type of, we deployed them like this. We're just kind of guessing if this works. Little L brackets, and they're just lying flat on them. Yes, these are plastic. And so to test this, we decided to go along an anthropogenic gradient from anthropogenic intensity from Peterborough down to Toronto. We had 3 sites in Peterborough, 1 at the Trent campus, just to the back here, 2 downtown. We had 4 along Highway 401, so this is the busiest highway in North America. Just around this intersection here, it's about 500,000 cars every 24 hours. We had a couple in downtown Toronto, so that's our 9 sites across the gradient. But we also had a background site where we collected moss, essentially from a conservation area, low on foot traffic, far from cars. If you go up there, look. So we collected Chlorosium shrubbery in this case. We can also identify that one from the Morsworth Caves Conservation Area. We constructed 23 moss bags, 18 were deployed across the 9 sites, so that's duplicate at the sites, and we kept 5 as controls, so essentially they were unexposed. And we're looking for that accumulation. So we want to know, do we collect moss above those, or do we collect microplastics in our moss above those controls? And we deployed them for 45 days along this gradient. I should note, we actually planned to do 5 minutes now? We did plan to do a wider distribution, but COVID happened. So this was our COVID pivot project, which also meant that, of course, here at the Peterborough campus, the one on the Trent campus was very quiet because it was shut down on the campus at that time. So what did we find? Microplastics observed in all moss bags. Put it in there beforehand, but basically 186 microplastics in the deployed bags versus 14 in the undeployed controls. And we found a range of fragments and particles, about 50-50 in terms of fibers and fragments, but the percentage varied. Peterborough was dominated by fibers compared to Toronto, which was dominated by fragments, and that gives perhaps some indication of proximity to different sources. The average accumulation, so that's greater than that background site, was almost about 10 microplastics per gram dry weight. And this ranged from 2 at Trent University, which I think was our most background site, to the Resources Road site, which is the one at the busiest intersection in Toronto, just over 13 plastics. And we had duplicates, so 30% variation between duplicates, which I think is pretty good. And so we had this gradient went from Peterborough to Toronto, to the greater Toronto area, and it looks like this. This is our background site. And we can see accumulation, no significant difference of these 2, but the greater Toronto area sites had the highest. So we thought, well, these things look like they might work, the pandemic thing. So we thought, well, if they work, can we use them to answer some questions? And we thought, well, are they useful to assess sources of microplastics, atmospheric microplastics? And so we had a study that we then carried out after this with the moss bags, assuming they worked. We said in rural areas, are microplastics from local sources, or are they from long range? And everything you read in literature that talks about atmospheric microplastics is always talking about long range, traveling everywhere, all over the place. So we looked at Lake Scugog, and we deployed moss bags, 11 moss bags around Lake Scugog, and about 6 of them were in very small communities. The largest community here was Port Perry. It's about 8,000 people, but we had a small community here, 1,000 people in Caesarea, another small community here, Seagate. So 6 of them were in small communities, the other 5 were in, I would say, places devoid of people. And we assumed that if it was all long range, they should all be the same, they should all be equal. If it wasn't, then there should be a difference. And again, moss bags deployed 11 locations, duplicates, 2 exposures, 4 months worth per bags. And this is what we found. When we looked at count, we had these, what I call low intensity sites, the ones far away from populations. We had an average of about 20, median about 20. Minutes. 1 minute left. And then we had these high intensity ones. And in terms of count, there was no difference. But we did have some other measurements. We looked at the shape, so we could see they were dominated by fibers, some fragments, some films, but we also looked at types of plastics, so rubber, polyester, nylon, and polypropylene. And knowing the density, knowing the size, we could work out the concentration, so we could work out micrograms per gram. And we could see quite a notable, significant difference between low intensity sites and high intensity sites. So even though the number doesn't differ, these high intensity sites were actually getting more plastics in the deposition. Suggesting that, of course, local sources influence atmospheric microplastics. So what next? A study that we're working on is this one. I think this is my greatest contribution to science, by the way. I come up with this acronym. It's Microplastic Atmospheric Deposition Assessment Using Moss in Europe, so the MANAM project. I thank ICP Vegetation because they're coordinating essentially through the network of countries that participate in ICP Vegetation and a few institutions. We've managed to get moss samples during the last survey following a standardized protocol. So we sent them out a protocol and said, please do this, just like this. And they sent us samples back. And this shows the location of where we've collected samples from. These dots don't indicate plastics, they just indicate the density of population within a 5-kilometer radius of each site. So this is what we're currently working on. And I know Mary's going to present results on this, not now, but in the graduate forum. Just gracias.
We have some time for a couple of questions.
Can you explain to me or us, what is the moss doing that sticky tape?
Yeah, you're right. I completely agree. I've asked the same question. So but I've got a couple of reasons for it, or a couple of answers that I'm making up on the spot. Right? Well, moss is widely used. It's got a high surface area. It's good at holding things in, and we can actually deploy them and leave them out for a reasonably long period of time, and then take them back. Whereas sticky tape, it depends on the size of the particle. It's preferential for smaller ones. Now with moss, we're still short presentation. We're still looking at the mechanism. It could be some ion exchange. It could be just that they're trapped in. We don't know if they stay there or how long they're held by the moss before they fall out. But we have used sticky tape. And sticky tape is tough to work with because everything's on the tape. Then it's tough to get it off the tape. It's tough to analyze it. And there is preferential in terms of just the number of plastics. And it's a shorter deployment time. Whereas with this, we find we can make them, deploy them, but there is some analytic effort at the end.
You can't just leave it on the sticky tape for the analysis?
No.
So I thought you used sticky tape for the FTIR.
Yeah. It's complicated, but it's really difficult to get them onto sticky tape.
Do your plastics include tire work particles?
My ones don't. Mary's going to present her ones, yes, actually some of them do.
I mean, I asked that question because of your transit towards the,
They do. I think the issue, if I was honest, and I could be honest here because no one's going to tell anyone, I know you're up there here. The issue is that, of course, when we started these studies, we were getting used to kind of identifying tyreware. Tyreware are difficult because I mentioned the hot needle test. If it melts, it's plastic. If it melts, tyreware doesn't melt. And so you go, oh, that's not plastic. So it's almost, it has to be rubbery, it has to be black and not melt for it to be tyreware. If it melts, then it's usually asphalt or tarmac. So that's the issue we've had. What we have is at least in the last study, there were some tyreware particles in it.
Okay, with that, let's, one more?
Yeah. Mark.
Go ahead.
I just said that your groups are like reputable samples. Do you really want to look at archival?
There are people, yes. There's somebody who looked at an archive of lichens. Lichens have also been used and other plants. So some people have looked at archive lichen samples, but the results are ongoing.
Let's thank Julian for his presentation.
Okay, it's my pleasure to now introduce Mary Jafarova from Trent and the University of Siena. I think the study that she's presenting today is from the University of Siena. Yeah, it's there, sir. Looking at a higher plant for the biomonitoring of microplastics, including tyreware. Should be in the folders. And the folder, yes. There's a folder for session. No, it's a desktop. Yeah, yeah, but in the folder, session, yeah.
It's ordered.
We've only got 2 minutes. Yeah, you hit the forward, backwards, and the light.
So today I'm going to talk about
That's right.
Click the screen
Click the
first.
screen.
Click the screen first.
Click the screen.
Thumbs up, questions, anyone? Maybe that image you guys.
Okay, so today I'm going to talk about the suitability of black locust leaflets as biomonitors of airborne microplastics. So, as in previous presentations already mentioned about microplastics, Julian's presentation, they are plastic particles less than 5 millimeters in size and can be in different shapes, and they are found in all types of environments, including human blood, in recent papers, and one of the main concerns tyreware particles, which I will mention in today's presentation. Tyreware particles, they are the abrasion of the tire treads on the
surfaces of the roads, and they are the recent concern, and they are one of the main contributors to the microplastics. And so, as my study is based on biomonitors, until now there have been lichens, mosses, and other higher plants such as lettuce have been used to biomonitor the airborne microplastics, and they are, in today's presentation, I will have a look if I will explain if black locust, how suitable it is for the airborne microplastics, including tire wear, particles, and all the analysis also were supported by chemical and magnetic properties because of tire wear particles, which I will explain. So black locust is a fast-growing invasive tree species, and especially in Italy, can grow like it is found everywhere. And so maybe it's good at least to make use of it, as it's invasive and has capacity to modify soil conditions and also shading the other species. And but they are easy to identify, and they have waxy leaf surfaces which helps them to catch the particles from atmosphere. So this is a study area which took part in Italy, and so we had 5 urban parks in the city of Siena and 5 remote roadside locations far from Siena, and mostly not like populated areas. But with 5-10 meters distance to the closest secondary or provincial roads. And for urban parks, the urban parks they were all far from the roads, because Siena has restrictions to cars, as it's mostly historical. And so all the urban parks were far from the main roads. And so the methodology, so we first extracted the microplastics, identified their polymer types, and also estimated the daily deposition, daily microplastic deposition, and then we did metal analysis and magnetic properties. And so microplastics, we washed the leaves and with very nice filtered, very nice water, and then it was filtered onto filter papers and cellulose filter papers, and then it was examined under sterile microscope for the microplastics. So during the analysis, we did quality control, such as we used process blanks, and then all the lab glassware that we used, it was rinsed by very nice water at least 3 times, and everything was covered by aluminum foil so that there's no contamination, or contamination was minimized at least. And then the surfaces were wiped in the clothing during the sampling, and also the lab analysis, it was all cotton. And so for the polymer type, we used microwave JR, and this is an example of the tire particle that we had found, spectra, with the match of 78.39%, which I will explain in the results more. And so the microplastic deposition was estimated, the daily deposition, based on the this formula. So we basically measure the leaf surface with this app, Leaf Scan. And then for the exposure time, as the sampling collection was at the end of September, and considering the leaf emergence that starts end of April, and in May they are fully emerged usually in Siena, and so we consider the exposure time 5 months. And trace also the metals. As we have roadside locations, so we have estimated that there were going to be tire particles. So that's why we chose the traffic-related toxic elements, such as these elements, and we did the analysis by ICP-MS to learn their concentrations, and also we did mass magnetic susceptibility to learn if there is any magnetic element in our samples to understand it better. So you might say, okay, there might be rainfall during this period. So this is the during the vegetation period. Unfortunately, in Siena, there's not that much recently rainfall due to dry summer. So during this period, we didn't have heavy rainfall. So it was just September at some point, but not during the time we had collected the samples. So the results show we found different shapes of microplastics, such as microfibers, fragments, and tire wear particles in roadside areas with this amount. This is the mean of tire wear particles in number in roadside locations. Each side, there are 5 sides, and each side had 5 replicates. So this is the mean value per 5 replicates. And you can see urban parks. So in urban parks, it was mostly, as you can see, they are all similar. And in roadside areas, there's huge difference in the microplastic amount due to tire wear particles. So this is the number of microplastics in total, and you can see the difference between the two. And so in roadside locations, it was mostly tire wear particles, very few amount of fibers. And in urban parks, mostly fibers and fragments with 4.1. No tire wear particle was found in urban parks. And the daily deposition was obviously, because of the tire wear particles, it was high for roadside locations, but in urban parks, it was just mostly fibers. So this is the daily deposition, still high. Polymer type. So we, with the FTIR analysis, we made sure that those, as I showed in the previous, the first slides, the spectrum of tire wear particles, I made sure that they were tire wear particle. And in urban parks, there were more diversity of polymer types, as it is actually populated, densely populated. It is located in the city, in the core of the city. So the closer to the source, there's a possibility to get more polymer types. But even though there were lots of tire wear particles because of the but it was still rural, so not so much diversity of polymer type in rural roadside locations. And this is the blend, microplastic blend. The longest fibers, so this is for the fibers, the longest fibers were found in urban parks, and there is much more high amount of shortest fibers, as longer, like fibers are less prone to be transported for long range distance. The fragments and tire particles, they were all less than 550 micrometers. So the magnetic properties, they were so low, these values are really low for, in general, to be worked further, for further analysis. But we just did the first step of magnetic analysis by just finding these values as they were so low, but there is still all these values in urban parks, they're all minus negative, but roadside locations, they were like slightly higher than urban parks. That means the samples were magnetic. That means that is related to roads. But urban parks were far from the roads, so there is no magnetic particle. There was no high amount of magnetic particle at all in urban parks. And out of the potentially toxic elements that is traffic related, we didn't find we chose these elements because they can be helpful for the traffic related causes, but we only found antimony was higher in roadside, it was higher than urban parks, the amount of, as you can see, slightly higher, not slightly. So again, this is related with the tire wear particles or brake emissions, so road-related source. So the outcome of this study, so higher amount of microplastics in rural roadside locations because of the tire wear particles. But if we exclude tire wear particles, urban sites had higher amount of fibers than rural roadside areas because of the human population and the habitation. So higher daily microplastic acquisition rate because of the tire wear particles in roadside areas, and for the fibers, again, in urban sites, the urban parks, and the urban parks, they had high diversity of polymer types, as it was in this study, all the urban parks, they were in the city, and all this outcome, it means we could use black locust as it has no good for other species, or it's just invasive, but we could at least use it for biomonitoring of airborne microplastics, including tire wear particles. So this study has been published recently, and if you are interested, you can have a look. Thank you for your attention.
Minutes for questions?
Yeah, I do have a question, and it's about how do these bioengineering methods compare to other methods in in estimating the microplastic concentration?
So in this one, we use washing method. But in previous studies, I have used digestion because as like higher plants are, I was using wet peroxide oxidation usually to digest, and like Robinia, like higher plants, they are not easy to digest with wet peroxide oxidation. So that's why we washed this, but the lichens and mosses, when we analyzed them, washing for them could not be really useful as it requires like for example, more time of washing, or we're not sure if it washes everything, so we are digesting with wet peroxide oxidation. But for higher plants, it is just the surface and nothing, like there is no structure like moss or lichen, so it is on the surface, and that's why we just washed it, as we felt it would be sufficient to take all the plastics, majority of it, the microplastics from surface.
Yes.
Can I add a bit to that? Because I think you were talking about also compared to traditional methods.
Yeah.
Yeah. I mean, I think the issue with microplastics is there's no standardized methods. With biomonitoring, of course, this means that Mary here could sample 10 sites easily without having infrastructure set up. And it gives a good relative assessment. I think here what you can see is there's a lot of tire wear particles in roadside locations in urban areas or in rural areas. So I think they're good at assessing over large regions, understanding spatial patterns, but not as an accurate measure of deposition, except maybe for the leaves here. There is a measure that you can get the area of the leaves and the exposure period, so it's a potential, but there's so many differences in techniques and people filter out different sizes, that I think the estimates of deposition from biomonitoring seem reasonable. Yeah.
I know we're really careful with washing and all that, but I'm just wondering if I noticed in one of the slides there is more of the smaller fragments than more of the larger fragments. And I was wondering if any of your very careful washing or filtration techniques would be breaking these larger fragments into smaller ones.
Sorry, you mean like couldn't wash all the small fragments?
No, that you might be breaking some of the larger ones, so you're getting more smaller ones, but it's a function of the process that you're using to clean sample.
Yeah, we are actually still pondering on that. We are breaking the originally entered, if the microplastic have been changed by its size has been changed during this washing process or wet peroxide oxidation. So we're still not sure about that, if we are breaking them or not. So it's a little bit hard to understand, as the methods should be improved to understand this point.
If no more questions, I'll say thanks again.
Our next speaker is George Smith, also doing his graduate work at Trent University under the supervision of Neil Emery, our primary supervisor. I'm going to be talking to you about some compounds which potentially have therapeutic uses that are extracted from a plant species from Guyana, and a little bit about some non-targeted analysis to identify those compounds. So.
Good afternoon, everyone. George Smith from Guyana, South America. As I approach my higher degree at the Trent University, I was given the opportunity to do some literature review, and what stood out for me during that process is natural products. And by having a background growing up in the forest for more than 30 years, live with the elders, see what kind of plants and stuff they use for therapeutic benefits. From that literature review, I decided I want to study Lepocarpus dentinatus, which in Guyana known as scapula. Right, it's in terms of its distribution, from here on, I will just refer to it as scapula, not a scientific name. It's widely distributed in South America as well as Central America, sorry, but most of its abundant of the species more in Brazil, which is also near to Guyana. However, in Guyana itself, the plant grows in mixed forests. There's a image here showing that length and stuff, so it's relatively abundant. However, there's no, so far because of the just natural use and stuff, there's no, I should say, fixed legal policies that actually protect it in terms of being a protected species because it's not endangered at the moment. However, it is being used, sorry. It's from the Diplocarpus, the Dillinaceae family, right? Also known as Diplocarpus dentinatus. In Guyana, there's one species, but there's two ecotypes of that species. The red is generally used as the utilized by most individuals, but based on traditional knowledge and traditional and utilization of the two ecotypes, people are claiming that the red is more for the male, and the one with the not so red color is used by the female, right? And based on that, it's known to produce or react in the body and claim to have aphrodisiac properties, meaning therapeutic properties. So more in commonly used in Guyana, when it's in various different types of products, people will say, okay, oh, it's capulula. So based on local uses in a local setting, it aids in increasing libido in men and also curing impotency, which is known as ED. However, there's no evidence to support such a claim to date, as well as there's limited bioinformatic research done on the plant and both ecotypes to support such a phenomenon benefits that's pertaining to men. So, having a chance to come to Trent and pursue a terminal degree, I decided these are some of the questions, since I choose such a plan to study, that I should take this up a bit more. So, providing traditional knowledge with scientific evidence to prove that, yes, if this plant really works, it could be not just as the scientific evidence to prove it, but also aiding providing information for the common person, I would say, that actually uses plant on a regular basis, providing information to them that, oh, it has some amount of medical therapeutic benefits that you could actually use in your product of promotion in terms of business aspect. So, set aside my first research questions, what type of secondary metabolites are present in plants, as well as is there a difference between the phytochemical profiles of these two ecotypes, as well what are the primary bioactive or bioactive activities of these secondary metabolites in both ecotypes. The research was actually conducted in Guyana, more specifically Eagle Mountain, which is about 200 kilometers southwest of the capital of Guyana, where we did collect the two ecotypes, looking at, because of the nature of the vine, collect that different lengths for different vines, and then grouping those, offer those 3 bilateral aggregates, grouping them to a composite sample so we could get enough representation to do analysis on the data set. So, since doing it in a untargeted approach, meaning the biome of the plant is there's lots and lots of features, and trying to get a good understanding what's there for us, we went to the route untargeted analysis using different bioinformatics software and also methodologics tools such as the Arbitra to get a good understanding so far of what's going on in the plant. So first we started looking at the secondary metabolites, terpenoids, polyphenols, alkaloids, and group those based on and look for bioindicators based on the relative intensity between the 2 ecotypes. Using a typical workflow that involves including metabolomics as well as different bioinformatic tools and databases to have a good understanding of the different metabolites within the plant, as well, because we're now using standards and see how far we could actually make representation in terms of identifications of these compounds, both in MS1 data and MS2 analysis as well, to give relative confirmation of some of the compounds that are present. So utilizing like KEG, GNPS, those are serious MS-diol, these are relatively known plant-based as well as plant-based bioinformatics database that actually utilizes standards to make identification of compounds that actually utilize both in human as well as in plants. So, go through the entire analysis, interrogation of the data set. We were able to make tentative analysis in terms of the number of metabolites within the 2 ecotypes, and also see if start to build a story if there's a difference between the 2 ecotypes. Yet at this point, we noticed that there were more tentative features in red compared to the white, just having a quick visualization of the features. Taking it a bit further, we use some volcano plots to prove our cases more. And here we see again, yes, there's more features in red compared to white. However, some of the biomarkers that we were actually targeting, for example, the polyphenols, we noticed were not so present in the white, but in the red, but they were more downregulated. So, because of the nature of the sample and using an untargeted approach, and the metabolomics itself is very challenging in terms of analyzing the data because of the dimensionality of the data sets. Using these bioinformatics software with different algorithms, we use the principal component analysis to analyze the data in terms of removing correlated data and replacing those with uncorrelated data, so we could have an understanding what's going on with both in the different ecotypes and see what's are similar between the 2 based on how they do those groupings. From that, we then look at the Pearson correlation analysis and put it in form of a heat map to have an understanding some of the intensities between the different MZs, and then take it from there to actually link those MZ to these databases to have an understanding of the type of compounds that are present within the 2 ecotypes. So far, we have seen that there's a higher number of polyphenols within the red compared to white, and these polyphenols are more upregulated. As well, looking at the pathways in which these compounds are more enriched in both ecotypes, we notice that in the red, there are more significant hits enriched in the different pathways within the 2 species, within the 2 ecotypes. after that, we wanted to also now bring home the case, but what's actually going on in the plant? Yes, the plant have these different compounds, claims that, okay, yes, it could do X, it could do Y. In this case, we're talking about increasing libido and curing impotency in terms of erectile dysfunction. So, using the different databases, specifically the KEC databases and the the other databases, we are able to bring our identification from a level 4 to a level 2. So the only outstanding now is to add standards and to confirm some of these the compound, which is kind of challenging as well because of the cost of standards and some of the compounds we are looking at. So far we were able to identify the epicatechins, which is on the catechin gallets, which are commonly found in teas, as well as in some other regular foods that we use on a regular basis, also in red wine, pomegranates, and all these other common fruits we use on a regular basis in our homes. So from that, we were able to identify what compounds are upregulated that are significantly different, within the two ecotypes, and also add that based on the literature, these compounds actually have antioxidant and anti-inflammatory properties. As well, when we look at the more global classification of the entire plant itself, and based on what the compounds that we were able to classify, we found most of them are found in the, despite most part of the plant has a large lipid-like classification, most of the compound of interest in terms of the antioxidant and inflammatory properties were present in the flavonoid, polypropionide classes, as well as the within these classes, these compounds are also known to provide removing radicals from the body as well. So the next part of my project is to deal more specifically with removing ROS, as well as looking at the phytochemical profiles of these two ecotypes, as well as trying to make a connection or correlation with the known compounds that we are tentatively identified so far, and use that to make a general approach to say exactly if these compounds actually, based on this significant, the correlation between them, see if they actually provide an indirect response to ED, as well as improving libido based on the synthetic approach of the metabolites within the plant itself, not when utilized by them. Thank you.
Yes, we have time for some questions.
I have to ask about the libido. So, I mean, what do you think it does influence libido, or is it just like any other, I don't know, red wine or blueberries?
Good question.
And where can I buy it?
The thing is, Capullo tells thousands of stories. Right? People have testified, yes, but from doing the research myself and using especially Orbitrap, so and the different bioinformatics software, I was able to narrow in, as I would say, 90% because of not utilizing the standards, that yes, this compound will provide some amount of benefits, but not directly like a blue pill, but using it over time and based on the synergetic approach of the compound, and compounds that work together, right? Some may upregulate certain activities within the biological system and aid to reducing some of the symptoms that lead to these stuff. So like the anti-inflammatory, antioxidant property, increase our blood flow, right? And clean out some of the RX, some within the blood, that may aid in reducing certain symptoms of the one.
Some flavonoids are phytoestrogens, etc. Is there any evidence that some of those compounds might be present in your extracts?
Again, yes, it's a possibility, but so far, based on the literature and some studies that I've done before, show that the levels of toxicity of the plant itself as well, when to other physiological approach is very low. And in terms of the phytoestrogens so far, we weren't able to identify one that is specifically present.
Okay.
But so far, what we see based on the small molecules that we did actually analyze show more positive results compared to the negative.
So, I mean, we deal with a company called BDS Biodetection Systems. They're in Holland. They don't come cheap, but they do these in vitro assays for various biomarkers of responses. So things like antioxidant behavior, estrogenic, androgenic, those kinds of things. So it might be sort of interesting to run your extracts through a series of those kinds of tests, see what sort of biomarker responses you see.
Yeah, that's good suggestion. Yeah. Based on the team, if we have the finance.
Yeah,
that's true.
Oh, we can talk about it.
Yes.
No further questions? Oh, yes.
I'm still back onto that. So,
Still back on the libido.
yeah, I mean, you said it's not regulated, but it is a product in tonic drinks and teas. So do they just go out and harvest it and make products?
Yes, we could.
Or is it grown?
In Guyana, it's grown.
For commercial use?
No, it's grown in the forest. Most persons let's go to the environment and the control is present. They will go and harvest, prepare a small set of treatments and different parcels, let's say like 1 kg parcel, and just go to the commercial areas and sell it.
Okay.
Other people piggyback on the traditional knowledge that it's good for ED, good for increased living, and quotas like that. So, for example, if some beverage has it inside and it's selling, does it force them to come on the market, right? The person comes to you and say, yes, this is a good drink, it has Capodul inside, right? So, with that connection from the traditional use, most men will actually buy it and drink it.
And does it taste good, or is it wine? Should I take red wine?
The theory is based on concentration, but most people use it with just like tea. Add milk, it prevent visualization like when you add milk like Milo. And across different diversity, people give different recommendations about this. But for me, I use it as just like tea, but now I'm trying to brew it like coffee, because you could grind the bark and put the same amount like in the coffee beer, like a seed extracted.
Well, I think we're coming up against the next session, so thank you for your.
I can ask questions now later.
Margaret, do you have some intelligence on when the next session will start?
Maybe if we can have a relatively short break, maybe 15 minutes, and then, so approximately 4:30. Yeah.
Okay.